And I have a passion of recently I developed passion of Gen AIs, and of course everyone is moving towards the AI. So of course I've tried to create this presentation. Since we have a shortage of time, I know it's like hardly 15 minutes, so I'm just starting. But I'd like to more going into the slides that is more informative that I can share it with anyone. I would like to share my experiences that I've along with this what they have. So that will be better because that will be more practical experiences rather than just theoretical stuff. Right? So okay. So shall we start? Okay. So let's start with the first. Okay. So just one question, since we have like some people, or what kind of experience difference we have over here, like freshers or like more than 10 or 5 years, 10 years experience or more than that? Like how many of ex completely freshers from here? Okay, nice. Okay, so I actually describe accordingly. And how many have like five in between 5 to 10 years of experience and 10 plus? Okay, nice. So I will try to like keep it moderate so that, and but definitely after this session, once we meet after this room, we can always have a discussion based on the use cases. And I'm sure everyone is working on different projects. I'm more than happy to share my experiences and exchange experiences over the different use cases of securities. So uh, let me begin. As we know that, of course, human beings are the biggest creators of the problem, and then we come up with a solution. Then it comes up with creating more problems, and then we create a solution, and that's called innovations. So we are fond of doing this. That's make it. That's what we call innovations and passion, right? Creating problems and then solving it, right? So that's what I start with this great Einstein, that we cannot solve the problems with the same thinking we used when we created them. So that's us human beings. Right? So just to start with, since we have some freshers as well, like today with a just one couple of lines of monolithic and microservices architecture, like this monolithic is a very traditional approach where we have all the files and all the functionalities under the one shell, right? Now someday some set of people thought, okay, now as we with the increase of public, with the increase of users, came up with a thought process that okay, that the users are increasing, that means scalability when it comes to, and but at the same time the problem is security is also increasing. Because of course there are always lots of threats on data is getting, like right now we are talking about more than petabytes of data. Lots of, we just don't need to archive the data, we want the real-time data sets and all. But all these things comes with some disadvantages as well. With the increase of data sets, with the increase of public users and all, that comes with a threat to that data, and that is something, the security. So that's why we say that scalability and security is one of the like top foundations of any applications with what we design. When it was monolithic, like then what happened is there was just one applications. It was very cluttered. It was very hard to maintain. We have multiple scenarios where all the functionalities in under one shell, and then of course it is very hard to scale them as well. Because just taking an example, if you go to the e-commerce platform, right, it is not necessary the person who is actually registering may also go and buy the product as well. So we started deviating. So we thought of, okay, with the increase of scale, to increase the independent scalability and to getting a hands-on over that, okay, right now these days the problem is that you cannot create one product with one technology, because it's always a collection of technologies that we create in order to create a great product, right? So we started thinking of, okay, we can go into a microservice kind of architecture where we can start dividing the functionalities into different pieces. We can scale them independently. We can create our own different tech stacks as well. And along with that, there will be, that will reduce the dependency, that will increase the delivery time. Because like in one of the use cases that I think most of you knowing is that if by any chance in monolithic, one of the problems that was that even there was a one functionality change, it has to go all the regressions and all. Because even if, for example, in application there are 100 functionalities, right, but there's only 2 additions, but it's still the whole monolithic application needs to test it multiple times before it goes to the production. That kind of issues was also solved in microservices, because that we have separated the functionality. There's small pieces. There's something called bounded context, business bounded context, that we use that term, particularly microservice architecture, right? So as it started breaking it, then further it started breaking into different databases. So depending upon that, like I can take an example that social networking platforms, we have different databases, like in different microservices, we can have accounts in one database, we can have feeds in different databases. And then even sometimes the accounts also, like for example, users is also divided into different databases as well. That there's a concept called shading. Shading is basically dividing the data zone wise based on certain criteria. That comes into the Oracle. We have all the relational and non-relational databases have these things, right? So of course, microservices, then further databases. Now, okay, now we have achieved one milestone. That's fine. We have achieved the scalability through these things. Now what? Now the problem is that when these microservices are communicating with each other, or any external UI, that is a UI is a client, it could be anyone, it could be the end user, when they start communicating, there's a lot of loopholes, because with increase of microservices, there are lots of endpoints has also been exposed. With those endpoints has been exposed, there's always a threat that, okay, that of course the hacker can always jump in from different sources. Maybe for example, in an e-commerce platform or any banking sites, if for example their accounts onboarding particular services, they try to attack it by sending lots of requests and the service goes down, then the user cannot register it into the internet banking. So with increase in these microservices, the threat will also increase with all. Now let me move to a different presentation. These are the security challenges. So as I said, like there are lots of there. I would like to discuss, but as I said, I will be discussing my experiences, not what we are currently implementing in the banking domains for the past 5 years and other domains as well, right? So these are security challenges that we come across when it comes to microservices. We have distributed attack services, inter-service communications, data consistency, dependency management, monitoring. Let me give you a brief about the microservices first, right? How many of you are actually working on microservices currently? Right, we have a lot, right? Then now the point is, when it comes to any microservice, as data, let's start with the distributed attack. We have different endpoints coming up, right? As I already mentioned, data inconsistency, authentication and authorization are two different things. Sometimes we get confused. First is authenticating the user, means I have a username and password, I authenticate the user. And then second is, even if I'm got authenticated in a particular platform, do I have where I have an access? When I came to this place, I have an access to this room only. There's a possibility I'm not required to get into that room. So that is giving a user a limited rights to perform their duties. That's what we have in like so minimum rights, giving minimum rights to a particular person. So that is something. And we usually do authorizations that come from the role-based, user-based authentications. Service discoveries and configurations. Since we have multiple microservices, point is how they will identify each other. If there's a microservice and B microservice, A can act, suppose there's a hacker who created a duplicate, a clone of A, and they try to communicate with B. How will I know that that A is the same person that I need to give the data, that I need to provide the data? Then of course we come across these secure. Then of course in a service discoveries and configurations comes that, okay, we should have different ways. Like for example, mutual authentications. They have some SSL, like client SSL. I have a server SSL. There's a handshaking. So I know that, okay, this is A is the right person. On top of it, sometimes we go certificate is also attached with the authorizations as well. So even if so, one is that's authentication. That's good. You're authenticated, that particular user, through SSL. Like we sometimes say that SSL is a big thing, but actually it's not. It can be bluffed. We can always mask it. We can always change the content inside it. Even if you go to a JWT tokens and all, right? It's basically 3 parts, right? You can always we change it if you don't provide us necessary authentications. Even if the person A has a SSL, and on a B side I need to authenticate it, I still have to break it, the same SSL that I'm getting into headers, into multiple parts. And then, for example, the SSL I'm getting in a headers, I break it into 3 or 4 parts based on header, footer, and body. I should, even on the server side, I should actually authenticate every piece of it, not only just blindly accepting the, okay, that guy, that particular microservice as a SSL, let's go and share everything. No, absolutely not. So that is one thing that is we also. So there's something called zero trust principle. I think some of you may know, right? Okay, any microservice, anything should not trust anyone. There should be always a proper protocols. There should always be protocol. As I said, even if the headers is, even for example in SSL, I'm getting from the headers, it is saying SSL 256, right? SHA 256. Sometimes there's a possibility that the hacker just copy it, but they don't know what is SHA 256 involved in it. They just put it none. And I say, it comes to me as a validator. I check that. Okay, it has some header. It's not just headers I need to validate. It also has to, I need to validate whether those SHAs, those encryptions is for that particular microservice or not. Just giving an example that there are, just coming back to the same example. For example, this microservice is only targeted on accounts, right? This accounts, I know that in a headers, I know this particular microservice comes and I check that, okay, it has a SSL. Second thing is that, does this particular microservice should have an access to a particular data it is asking for? That is the second thing. Third thing, even after dividing this headers that I'm getting, body that I'm getting in SSL into headers, footer, and body, I should know that, okay, that particular microservice, suppose its name is accounts. Does this accounts is entitled for particular encryption or not? For example, to make it more secure, what I can do, I can say that, okay, this account should only be entitled for, I'm only expecting SSH 256 from this particular account service. By any chance, hacker even change it, replicate it, and they send something else, I know that accounts is only comes with SSH 256. I will not accept, I will just discard anything else. Apart from that, of course, the tokens, body, and of course the handshakings, of course, that is also needs to be validated. So in nutshell, what I'm trying to say is that never trust anything that is just because it has some encryption and all. You should always validate every piece of the section that is coming to you. So like we have dependency managements, monitoring and incident responses, like basically anything that is like, for example, if any anomalies or any kind of a defects that is, so we can always highlight that risk that, okay, this, I will come to a secure AI-based scannings and AI-based security tools that we can use in order to secure it, because just to reduce the human interventions. So their last 2 slides is basically, so I will jump onto that very quickly. Right. In a micro front ends, maintaining micro front ends is also another big problem, because how much like layers you will add on JavaScripts, right? So when it comes to React, what we are doing is like these days, even I think, do you have an experience with JavaScript frameworks and all? Maybe, right? So what we are coming up with a kind of architecture is like, even if I just taking an example of React, we have created a separate node layer that is actually controlling the anything that is coming inside the application and going outside the application. In microservices side, we have n number of options these days, right? As we come across, I will show you. There's a list, right? But on micro front-end side, we have a limited option because lots of code is already exposed. So that is something that we need to protect as well. So what we are doing is in React, even if it is a React or Angular, we have created separate node layer that is actually managing all the activities that is coming inside or outside. So what we do is, like, for example, taking a React example, we build the complete application that is just a UI and everything. Then we build it, and then we call those routes to the node, and any other, for example, API request that is going, we use a proxy environments in order to maintain it using interceptors. So even if even for example, a request is coming, so we know that, okay, this request is coming, is this person authorized or not, is the proper content security policies are enabled or not. So anything that's, for example, just so if person A is like getting into a UI, right, it just gets into it, What being a VA scannings can do is they can always send n number of different requests to the node. But since we have a proxy environments, proxy servers, we can always intercept it. We can scan it using XSS, whether it is clean it, sanitize the data that is coming in, and also route it to a different place. We can also add that where we are expecting. We have helmet packages as well in JavaScript, where what we can do, we can always restrict it that we are expecting it only from these domains if we are actually accepting any data. And just giving an example, I was calling React application inside the Salesforce environment. Salesforce put lots of restrictions when it comes to the content policies because they don't want any hacking attempts, right? So we used a helmet, of course, and then I have to put all the particular domains that is accepted by the Salesforce, and in order to get it accessed, and then further restricting that, okay, only CSS, only HTML should be accessed, not much JavaScript, even on a level of JavaScript restrictions, images restrictions, we can always add those things. Right? Secure API consumptions, that's what we say. Using the proxy environments in order, using interceptors, using cleanings, proper sanitizing the data, that is required. Content security policies, as I already mentioned, that when it comes to the anything that is even anyone who's accessing it, we can always apply those content security policies that, okay, what can be accessed, what cannot be accessed. We can always apply those kind of content security policies. For example, if I want to block the JavaScripts completely, yes, I can do that so that anyone cannot induce any kind of injections or attacks inside the application. Dependencies and third-party risk. Sometimes what happens is, just giving my recent example, that we have a VA scans and black duck scans, SNYK scans, as you know, SNCC scannings, like especially in these days, all the giants, we have these things. There are lots of transitive dependencies as well. Even if, for example, we have installed a dependency A, just take an example of React, but it has lots of transitive dependency and it is highlighted as a risk. Then of course, we need to make sure uh, sorry, we need to make sure that, okay, upgrade the proper dependencies and the third party, like, of course, so that all the vulnerabilities needs to be properly rectified. Then what are the shared security challenges is consistency securities across, and of course centralized loggings. Compliance and regulatories are important because, like, you might have came across that Google has been fined recently, couple of years back. It has been signed with billions of dollars off because of GDPRs. So I was also involved in that. I was also the part of that team where we need to clean all the PII informations and everything in order. So because they've been fined and we need to remove. What happened was, one of the Google has multiple verticals. Now you might have noticed in your mobile, there's sometimes the card appears. They create a complete customized card for you for your when you are, for example, if you are having flights and all, right? You get a card, pop-up cards from the Google, and sometimes some one of the scenario was, it was also showing the PI information encrypted in it, or PI information was also part of it. So we need to mask everything because they were heavily fined. I think these days you will see lots of banks are also getting fined because of these different norms and all. Right. Yeah, please come. So compliance and regulatory requirements is also important. Like, oh, okay, I'm running out of time.
Yeah.
Yeah, yep, please go ahead. Yes, we have. So for security scannings, like, of course, I've listed down as well. So since it is 5 minutes, we can always discuss it outside. Just to answer this, for dependencies, usually the editors also have already dependencies. Even if you go to IntelliJ, there's always a dependency tree. You can check that. But on top of it, there's a SNY 80 CLI scans, SNYK scannings, black duck scannings you can do. It's always suggested that whenever you're pushing the project to any repositories, it's better to scan it with all the dependencies and keep your base up to date, right? But of course, I will give you more insights on it. Just quickly going through this, of course, when it comes to security, we cannot forget OWASP, right? They're quickly, like, of course, broken access controls, cryptography, injections, security loggings, that some of them I discussed. What we are doing is, in microservices, we are using APGs these days. Because APG provides more flexibility when it comes to token-based protocols and applications. unique routes we have created for within the APG. So like APG further divides into external and internal. APG is a gateway that has been created by the Google that is now getting accepted in lots of companies because of its flexibility and AI driven. Now we are coming to implementing access control based on principle. We have multiple auth scopes, client, permission based UAM. As I mentioned, that based on different, like whether it's a Java, like of course based on roles. Like you might have heard about IAMs in AWS. It has groups, roles, and user level authentications you have. So every company is like kind of following those. That okay, like which level of access do you need to add. Like just giving an example, auth scopes, each token issued contain only the scope required for the client task. Minimum access for that particular user. For that, if I'm only authorized to enter into this room, I cannot enter the other room, even I got a authentication by getting into this building. So these kind of restrictions sometimes we apply when we are actually a user is calling. So that's why we prefer that we can do, sometimes the authentication server and authorization server is same. Sometimes we separate it further when it comes to highly scalable applications, so that in order to prevent the data sets and well. Sometimes it is not a separate microservice. We add it as a utility and manage it through the cachings, all the all the data sets, roles, and everything that is coming. Like in case of Netflix uses they have a complete that it goes in. So just to give you a quick insight about the edge computings, where we are actually there, you might have known about the edge computings as well, where we are authenticating a data or authorizing it at an edge rather than person getting into the till the centralized. We actually authenticate the user at a very ground level. We use these things especially in IoT where it is not where the data frequency is really high. We use these kind of techniques over here. Of course, that's a quick combination of these access controls, right? I'm just giving an example of microservices architecture where we prefer that we, and let me take our example of one of my microservices that we are actually, we have in OpenShift, we have like config maps, config secrets, where we are actually distributed our configurations. Further, we have the configuration, we can use a Spring Cloud Wallet. For example, we should not share the database passwords in our system. We usually use it CyberArks in order to get the credentials into our systems. Further, adding the token level protocols as well, one-time use token, or two, we are using it. So you can see this Spring Wallet. Yeah. Just jumping onto the thing that is one of the like a fascinating these days is just one liner that human cannot do everything. We are actually gradually in 2025 from 2024 end and from now many years from now down the line, what we are planning to do to use the AI workers. I think you might have heard about the articles that Microsoft has recently launched that they are using AI work, training the AI workers. Salesforce has also coming up with the AI agents where they have started training it gradually. That doesn't mean that we'll be jobless. The point is that that of course they are training the agent workers in order so that they can actually, uh, of course, do for the base level work. They can actually use it, use the AI workers, not replacing the whole hierarchy, of course, but on the other hand, we also came up with, you might have heard about, there's an Austin-based firm that came up with a protocol, with a AI HR interview, who actually takes the first level interview on HR side, and then it comes to the second level. So these developments we are having, and you will see lots of in next many years from there. It already has started. We are also working on initiatives as well, where we are creating our own AI workers, where we are actually, it has a basic capability that can actually, just giving an example, that even I'm working on, I'm one of the part of that core team where we are creating the AI worker that can actually just giving a user stories, it can create 60% of your application completely. And then we just need one expert who can just do the linking and everything that's done. So that is kind of reducing. If we have 100 developers, maybe we can reduce it to maybe 20 as well. And not disappointing you, but just giving you a reality that is going to come in next few years. You will see lots of AI workers and coming into picture, right? So like similarly in security and microservice through AI, the thing is we cannot secure everything. There could be millions of cases that we come across, but what we can do, just of course these things you can always, I will share the presentation, but the point is creating the models that has so much data inside it with different scenarios. So recently I created a LLM that can actually identify action. We already have lots of LLM, and now we are working on the security LLMs as well, that okay, based on the different patterns, it can identify okay, it comes in a different thread, and that is a required action. Based on that, AI will have a certain level of rights in order to take a definite actions. For example, if I'm a user, I am misusing my rights inside the application. If I try to, it will just check the patterns and it will block my access for temporarily, or till the administrator comes in, right? So these kind, so we're giving minimum, creating those AI agent workers. Yes, 1 minute. Yeah. So giving a AI agent workers a sufficient right so that they can act accordingly. For just quickly, I've also given the preventions and all, like threat detections, definitely anomalies detections using models. We have different tools as well. So we can go through the yeah. Yes. Yeah. That will be like, of course, just giving a just quick thing that it's not important that okay, we should use these tools, but we should always not buy them always. What I prefer, sometimes what I prefer, I use them, I get an idea, and I think of creating our own tools who are better than this. Sometimes I prefer, that's my approach. But yes, but of course, wherever we can always plug in at a minimum cost. Cost is one of the important factors as well. Darktrace, Victor AI, Microsoft, Splunk, Google Security tools. Similarly, we have some of them in the security and micro frontends as well. Similarly, Darktrace, of course, Microsoft Azure Active Directories, Elastic Machines Learnings. I suggest them to use them because they have a huge model. They have a huge database that actually, of course, identify lots of threats in it, and then try to create your own models. That's what I also started doing as well. That okay, how I can make up something that is better than this. Okay, that's what we do actually. We learn and we develop, and then we, because not every company is open for having a, like, just give you an example, like these days, like there's a trend that okay, time is up. Okay, we can always discuss. Just please. When you talk about having your own model, yes. What base model do you use for that? We create a. Developing your own model is a different game altogether. Right. But you can pick up a model that's already written and then train it, right? Or put all the information in it. So there are two things in it. One is sometimes these models are licensed. Like for example, if you have one model, right? As a company, I have to get the rights from you. I have to pay you certain amount, and you may ask for the royalties and all these factors. If these models are free, right, then definitely, and we get all the NOCs and everything, then we can use it possibly as a base, and on top of it we can always create it. Like just give an example. I was working on neural networks on for lip syncing. We know that there's already a models that we have. We started creating our own on top of it by using our own banking domains, and then I mean all the banking videos and extracting the data and then creating on top of it. But as I said, like yes, I can always share the list of models with you on this slide that we are using. Some of them is actually restricted within the banks, but I will share some of them that we are open source. I don't have a list right. Yes, yes, exactly. But as I said, just I don't have it handy because I was actually I don't have it handy, but I can share with you actually. You can always. Sorry. Thank you so much. Oh, sorry.
Can put that on here?
Sure.
Right here? Yeah. Gotcha. No, it's on here. Sorry. I think it does. It's on this side, I think. Yeah. I got mine. How do I share? Do I move it?
You have the link, the stream.
I do.
Okay, try sharing your screen, or you can share.
Well, it says I'm already sharing.
Stop sharing and try doing it again.
Okay. Share screen. Okay. Entire screen.
Anything. You
Okay.
can share this Chrome tab or anything.
This one? Yeah. Okay. And then do I just click and drag the?
No, I mean, like when you're sharing, you're sharing this.
See it, you see it now.
Yeah.
Well, you see it, but I don't.
See what's on the screen.
Okay.
Yeah. You try pressing the share. The presenting.
How do I?
Um,
Is it?
Can you use your mouse, or you can start with slideshow.
Yeah, but I don't have it on mine. Like I had to click and drag it over here.
Oh.
Like I was trying to see if I could do it. You know what I mean? Where it's like I'm. No, like instead of having two screens, just have it be one screen.
Oh yeah.
Like
Your
mirror.
display settings.
So is it one of these keys?
No, just hit the Windows key. Windows key. Hit settings.
Well, this is a Pop OS.
Oh, it's not OS.
Yeah, yeah.
So you want to mirror this, or do you want to?
Here, I just want one. Display. There we go. I think we're good now. It's doing something. All right, I think we're good. I think we're good. All right, my name is Andrew Ruulkava. I'm doing a talk on, here's the title of my talk, From Zero to Hero DynamoDB Essentials and Integrations for Java Developers. Sorry, I was freaking out because we're all in a hurry. But yeah, let's just get started and get going into it. Just real quick, kind of like the background on my talk. How many, I'm sure I know my buddy Gangsta has kids, but mostly people who have kids, I don't know if you do, but I have a 6-year-old and a 9-month-old. Now with the 6-year-old, he's real picky about his food, right? If I try to get him to try something new, he's like, he doesn't want to try it. And sometimes I feel that we as developers are kind of the same way, right? Like when you want to, if you're used to something, especially when it comes to the motivation for my talk was because most of the times we're all used to relational databases and we like relational databases. And coming into something new is kind of like you're a bit skeptical, right? You're like, I don't know if I want to try that. I don't know if I can do that. Yeah, exactly, right? It's just like a kid, right? Just real quick, a little bit about myself. I'm a lead developer for a company called 806 Technologies. We're down the street off of Tennyson. I do full stack development there. I do Java and Vue.js. I don't know if anybody here, like everybody I talked to at this conference, like 99% of everybody does React, right? Like I haven't met anybody that does anything else. I think Josh, I was talking to last night, does a little bit of Angular. No JavaScript ever. Okay, that's awesome. I'm also AWS developer certified and associate solutions certified. Although I think those are fixing to expire, so it's going to motivate me to keep them on there, right? Like to go renew them because someone's going to ask me about it at some point. Just real quick on the history of DynamoDB, right? Kind of the motivation behind it was in 2004, Amazon had a meltdown on their website, right? I think it was on a Black Friday or Cyber Monday, one of those days. Everything just crashed, right? And when they were doing their analysis of it, they were trying to figure out what exactly caused it. What they were realizing is their database just couldn't keep up on that type of massive scale, right? And I think I'm trying to remember the number of joins, but they had so many joins in their shopping cart queries, and the majority of them, they were just taking certain pieces out of it, right? So this query was just super big, and it couldn't keep up. And I don't know if some of you have had that type of background, but I've had 2 bosses in my past who are data warehouse guys, and their natural inclination to everything, right, is like, let's just break this down into like 100 tables and organize everything really, really nice. And then when it comes time to go grab some of that data, right, you end up with like 30 joins to grab what five pieces of data. Quick history note though, does anybody know why that is the way to do things? Like why break up all the data like that? No normalization, but what was the reasoning? What was the motivation behind it? It's not to duplicate, it was to save money, right? Because back like in the 60s and 70s when storage was just coming out, it was like super expensive to duplicate all that data everywhere, right? So you only wanted it in one place and one place only to keep your costs down. Now, over the years, what's happened, right? Storage has gotten like super, super cheap, right? I think I have a USB drive that's like 128 gigs, right? I mean, that was like crazy back then, right? That probably would have cost me millions of dollars in the 70s. Anyways, so out of that motivation, Amazon started looking around and they did this paper, right? They wrote this Dynamo paper, and out of it, it came out with these like guidelines, right, of what this database would look like for their specific need. And it was a white paper. I definitely encourage you guys to go check it out. I mean, it's very high level, but it's very interesting. But a lot of people read that paper, and as a result, we had other databases that came out around that time. I don't know if you guys have done Cassandra. Cassandra was one of the databases that came out as a result of that. I think that's still around. Ryek was another one. Voldemort. I think Azure Cosmos DB draws from that paper. In Gangsta, you've done some Cosmos stuff in the past. So a lot of it got that conversation going, right? And that was in 2007. Fast forward to 2012, and Amazon releases what is DynamoDB. So exactly what is DynamoDB? The short and sweet version. It's a fully managed NoSQL database service provided by AWS, right? And it's like, okay, what exactly does that mean? What does that buy me, right? So you get scalability and performance, and this is really what it was made for, right? It was the ability to keep up. I think trying to remember their P ratings, but they want to keep a consistent amount of performance no matter the load, and it's insane. They haven't done it this year yet, but I'm sure they will here in a couple of weeks. But every year, and I encourage all of you to go check it out. Every year, Amazon releases the numbers to what their performance was like, right, on Black Friday and Cyber Monday, right? They tell you what it was able to keep up with, and every single service, tier one, a tier one service in Amazon has to run on DynamoDB. I mean, that's how much they believe in it, right? The amount of scale that it's able to handle. I read one the other day, a guy was doing like, I think over like 5 million writes per second to DynamoDB, and it just consistent, right? It never, like, you never saw crazy spikes and anything. It's just, it does it. And then the best part of it, right, is you don't manage it, right? As a developer, are we responsible for managing? Do we want to manage any of this stuff? Not really, right? I kind of want offload that to somebody else and have somebody else worry about that. So it's got, again, high availability, fault tolerance, all that stuff that you expect, tunable consistency, integrated security. The integrated security thing is pretty cool because you can be as fine level as you want using AWS's IAM, and it gives you just a lot more control. And then also, you get some benefits of cost efficiency based on how you want to provision your tables and so forth. The global scalability and global tables is a pretty interesting feature that came out a while back. I was talking to a buddy of mine the other day, and he had clients in his client was in North Dakota, and they had this product that they were coming out with, and it was doing so well. And then they started getting customers, like I think like in Israel, and the Israel customers were like, hey, like this thing's running real slow, right? The like latency, right? Well, because all their stuff is in what region? It's in region 2 or US West 2, which is I think like in Oregon, right? And you're in Israel. Well, you have to make that trip all the way across, grab all that data, go back all the way across, right? Well, with the global tables, you could set up like this DynamoDB to be a global table and have it close to a region where your clients are at. And guess what? You end up reducing latency. So it comes with that. And the best part is you don't have to change your code at all. Your code stays the exact same, right? That's all handled for you. Some use cases for it, right? It's use cases for DynamoDB is it's great for web apps, mobile apps, IoT applications. I think I don't know. Trying to remember the guy's name. Is it Alex Debris, the guy who wrote the DynamoDB book? I think that's kind of how he got started. Somewhere in the IoT applications, gaming, and of course, Amazon uses it for e-commerce, and it lends itself very, very well to serverless applications. Who here is doing any type of serverless applications? Anybody here? Yeah, right. So if you do any type of serverless, right, the relational database is not going to be your preferred approach, and the reason being, right, because of the resources in the collection. I mean, the connection pooling, right? If you have these serverless applications like on AWS Lambda, right? You can scale from 0 to whatever, right? So suddenly you have 500 connections that are all going to your database without the connection pooling and all those other things in it. It's going to start to bog down the resource, and relational database just wasn't made with that in mind. And that's where I think services like DynamoDB just really, really shine when it comes to serverless applications. So let's think about it here a little bit for when it comes to relational databases, because that's what we're familiar with versus a Dynamo database, right? What are some of the differences? Well, for one is the data modeling aspect, right? The way you model your data is going to be very, very different. Whereas in your traditional relational database, you want to break everything out into the denormalized, or put it onto the different tables and so forth. Schemas in a traditional database, you have a fixed schema, right? I have a customer table, and I know that a customer table has first name, last name, email, phone number, and so forth, right? It's all fixed, and you have to know that up front. With Dynamo, it's schemaless, right? And you can add those things as you're going along. Now I want to track this other extra attribute. Well, you don't have to go out and modify the database table, right? Like normally in the traditional database, right? At my shop, we use Flyway, right? If we want to modify the table, add an extra column, I have to do a Flyway script. I have to do all these things and then apply that to the database. With DynamoDB, it's schemaless. Now it's schemaless, and it's not to say like, oh, I can dump whatever you want, but you have to be smart about how you organize that data. You still have to worry about that. Scalability. Traditional databases, most people would back in the day when I was getting started, Oracle was a big thing, and if you wanted to scale your Oracle database, you just give it more CPU. It's more of vertical scaling, right? You can do some form of horizontal scaling, but it becomes a bit tricky when you're having to manage all the different pieces that go with it, such as your clustering and how you shard the data, how you break it up. Could become more of a nightmare. DynamoDB is not made for vertical scaling, right? It's more of I have all these machines. How am I going to effectively horizontally scale? So those are some big differences. Query languages, right? Traditional databases, we have SQL, and it's great for most of that. You're not going to get a lot of that SQL-like behavior over on Dynamo just because it's different, right? Joins and relationships, right? In traditional databases, again, you can join to all these different tables to create all those relationships. Joins really don't exist in DynamoDB, and again, I mean that's by design, right? Because they don't want you to go to all these different tables. You have it all kind of just in one. And then cost structure, right? In Oracle DB2, those other types of big databases, right? You pay for licensing, right? You pay a license per CPU, and it's charged a certain way. DynamoDB is really not priced out that way. It's priced more of a, think of it more like a utility. What you're using, how you is, it's basically based off of usage, right? So if you're not using it that much and you're not writing and reading to it, you're really not getting charged for it. But once you start using it, you know, more reading and writing, then you start getting accruing charges and so forth for it. Yeah, so it is, it goes more, I mean, it's truly more of a serverless approach, right? Kind of like what, and so forth. I'm sorry here. Yeah, so just some quick basics, right? So we can become familiar with it. You still have the concept of tables, right? Tables still exist. You have items, and that's what they're called in DynamoDB. Item is like a row, right? Think of an item as a row entry in your relational database. You have the attributes that are associated with that item, right? Again, attributes are very similar to what you would have as columns in a database, right? And now this is where it starts to get a bit different, right? You still have the concept of, I need to know how to go grab a record. And you have this concept of partition keys and sort keys. So every item will need a partition key, right? Or every table needs a partition key, which is the primary ID to go get it, right? So if you have a customer, right? You have customer ID 1234. Well, that's an ID associated to that customer. That's the primary key for that customer. Now, this other piece right here, the sort key, this piece is optional. You don't, every item doesn't, or every table doesn't need a sort key associated with it, but you'll start to see here in a bit how sort keys do help out. And sort keys are very helpful in organizing and filtering data within that same partition, right? And it enables, it's what gives you the ability to, you know, like I want to go grab all the orders for this specific user. It's where the sort key kind of comes into play and starts being useful. Again, just real quick, partition keys are mandatory. And you want to be really, really smart on how you develop these partition keys. And that's another thing that I think is interesting. Forgot to say this, but when it comes to DynamoDB versus your traditional relational approach, right? And your relational approach, you can afford to be lazy a little bit in the sense that, like, hey, I start off with this modeling thing. I have a customer and they have orders and all these tables. And then like later on, you think of another relationship and you can kind of bring that other table into the mix and then create the foreign key constraint and tie it in and later join that way. DynamoDB, though, on the other hand, one of the things that I do tend to like about it is you really have to think about it up front. There is this, what I call the upfront tax, where you have to think about what your access pattern is going to look like. And most of the times it's very obvious, right? Once you start talking about what the application is going to be doing, you start to see the patterns that are emerge. And okay, I'm going to, you know, if I have an e-commerce site, well, it's based on a customer. A customer can do what? A customer can have orders. That order can have, you know, products. And you kind of, you start to model it, but you know how you're going to be querying that data. And again, the better that you think that out, you're going to have a better experience when you're working in DynamoDB. And it's not to say like, hey, I can't change it later and I can't migrate to a different pattern. You can totally do that, but you definitely have to think about how some of that upfront. And here's a scary thing that if you guys ever have a chance, definitely go online. Check out some of the AWS reInvent talks. There's a guy out there, Rick Houlihan. He's done an amazing amount of talks on this. Alex Debris, the guy who created the DynamoDB book, talks about this. But there's a scary thing called the single table design, right? Again, I come from the traditional relational database, right? I want to break things up into as many tables as possible. And the single table design kind of goes against all that, right? It's saying like, hey, for an application, let's just throw everything into one table. And it's like, it just flips that paradigm on its head, right? Because now I'm having to store everything. And so what is a single table design, right? Well, it's all the data in one table. You do a partition key for grouping, right? How you're going to group that data. And then you have a sort key to kind of make the connections and make the relationships. And then you can add some indexes for advanced querying. Just want to make sure. Some of the benefits of having the single table design is optimized query performance. The data is all co-located in the same place. Querying for all the related entities is efficient because it's all on one table versus spread out and having to do the X amount of joins to get you what you need. Reduce costs, it eliminates the cross-table joins. You don't have to go out and do all this, and you have fewer read and write operations because it's all just, based off of one table. Simplified schema management. You don't have to do as many updates and migrations and all this stuff to the tables because it's all on just one. And again, because it lends itself to what it was for, the scalability is going to be there. So again, when would you want to use the single table design? Well, again, when you have a well-defined access patterns, high throughput applications, and strong related entities. It does present a learning curve, right? You have to get used to it. If you're interested in the single table design, is just go out and do a couple of data modeling exercises. And the first couple of times that you do it, I'm not saying everyone's going to be like me, but it takes a while for you to kind of like wrap your head around it. But once you see it in action a couple of times, it starts to become just, like the second nature, right? I have a buddy of mine who does serverless applications at his day job, and he uses DynamoDB every day. And he's like, I start every single project with single table design. He's like, I try to define all my access patterns up front, and I do it off of that. And he's like, I can just do that, with like, it's easy now, right? Because he's done it so much. The first couple of times, you're left like, well, how do I tie this into that? And is it going to make sense for me to, and the inclination is going to be there. You're going to want to break it up into another table, right? You're going to say, I should have another table to put this in, right? So this is what a single table design would look like, right? You have a partition key, you have a user, a hash, and then some kind of ID, and then it ties into the sort key, right? You have a user, profile, and then all the attributes associated with that, right? You have a user, and then their order, and that sort key, you can start to see how it's like, okay, I know that it's going to have all this order information. Well, then all that order information might have products and so forth, right? And then you have like a product, and then its details, and it starts to like, lay it out, and you can start to see how that data is going to be organized in one table. Right off the back, right? It doesn't look right? Because you're so used to seeing, I'm going to have a user table, I'm going to have a profile, order table, I'm going to have a products table. Well, now it's all just kind of mushed into one. Real quick, this is how a query would look like in the single table design. You have an e-commerce table, you have partition key, sort key, and how you start to build, the user with the user ID and the profile and so forth. So I'm coming up on time. I'm just going to go through this real quick. I started to work on, when I was originally doing the talk, I thought it was going to be an hour. And so I started working on this crazy demo, and I was going to do a Vue.js front end and so forth. I'm going to condense it down, but I started to work on a taco ordering API, right? I want to order tacos, and what does that start to look like, right? And I wanted to apply the single table design. And I remember I was doing it and I was like, well, in a normal relational database, right, if I'm going to have the menu items, that's going to be a separate table. So for the dimensional lookups of my menu items, how does a menu item go into my taco ordering table, right? And I start to think about it. Well, I can use that partition key, right? The partition key with the sort key to create the entities, right? I have a menu item hash 001, but the entity could be taco 001. And so that's my menu item, the taco, and then the associated attributes. I have a menu item, a topping, and then the attributes that go with it. I also have a menu item and the side items. And so I start to model all that, and I come out with this, grabbing a menu. Now, this is going to take a minute because this is a Lambda, so it's not as warm as it should be. But after that, it should be pretty fast because I have a warmed up Lambda. So like now when I do hit it, it's pretty fast, right? So I grab a list of all my menu items, and I start to see like, okay, I have my ID, my name, price, food item type, and in the code, these are all tied to like the food item type is tied to like an enum and so forth. And I have some of the code, right? Like the menu handler, how I grab that, right? I'm using the menu partition to go grab me all the. So this is what the AWS SDK looks like for DynamoDB. But you can grab all the attribute values that you're going to want. You start to build a query. I do like the API for this. It has that builder pattern, right, where you just build on top of it and you chain it all together and you have your query. I grab all my items. I convert those items into my menu item object, and I start to build off of that, right? I created all the CRUD pieces, right? I have one for creating an order. I want to create an order. This is what the body would look like. Now, mine was a bit different. I used my email address. I used an email address as the customer ID because I know that email address for a customer in the app is really never going to change, right? Like on McDonald's, when I sign into McDonald's, it's signed in by what? By my email address and my user. If I try to sign in with a different email, I have to create a whole new profile. I can't just say like, hey, I want to change the email now on my profile. It's not going to let me do that because it's tied into that email. So for my use case, I was like, well, yeah, I should do the same. So instead of creating like a UUID for the customer ID, well, I just want it to be my email address. So in the table, I should have probably pulled that up. It would look like customer hash a.rubalcaba@806 Technologies. Yeah, and that would be the profile, right? So it would be customer hash, the email address, and then the sort key is profile, and that has all my profile stuff, right? And then I want to create an order. Well, it's customer ID hash, my email address, and then the sort key is the relationship. So it's order hash, and then whatever the order ID is, and then I get that, right? So I'm going to create this order. All right, I got 2 minutes. I created the order successfully, and now I can go grab all the orders that I want for this specific client, customer, which is myself. And here I grab all the orders that I've placed. And so here the order ID again goes back into, that's the order hash, order ID with my customer. And I can go just, hey, I have a customer. I want to grab all the orders. And it's very fast and efficient. And I don't have to do all the joins. One of the things that I did do for my use case is I was like, okay, well, I know the taco information. Like once you have an order and you've placed it, you really can't you really don't go up and update it again, right? Like most of the times, right? It's like when you go to the restaurant and you update the order and you're like, oh, I want to add to the order. Well, you've already paid, it's already closed out. You have to do a separate order. So I'm not updating I'm not going to update any of that information. So I just denormalize that and I put that along with the order. I don't break out every single Taco into its own sort key and all that. I kind of just put it all in together because I'm not going to really be doing any type of updates. What I am going to be updating in my use cases, I really just want to update the status, right? If I have an order and it's in receive status, I want to update it to completed. Well, it's really the status that I'm updating. I'm not really updating any of the actual items in there. So I do have like a, see if I have time real quick. I have like, this is the order ID. I want to update this. I have this information. I know the order ID and I want to put it to, I think I'm missing something on there and I'm running out of time, but I have a handler that's just for updating the specific message. I mean, the specific order. And then if I was to go get it, it would do it. And I can also just query by a single order to grab all the information that I need. And again, the order items. So I have all the code for that. I'm going to update it into, I have a Git repo. I'll try to post it on my Twitter and LinkedIn. I don't have a link to it, but if you look me up, I think I'm under Andrew Rubalcaba on GitHub. I have the code on there and I have some Vue.js code on there as well. I know I ran out of time. I wish I could have gotten into some of the more, to the actual APIs, but the code is there for you to be able to do a lot of the CRUD capabilities. More about me, again, I'm Han_Cholo on X. I'm not on Blue Sky yet. I think I created one a while back, but I've never really went in and interacted with it. Seems everybody at this conference is moving over there. And then my name is Andrew Rubalcaba. I'm on LinkedIn. Please shoot me a message. Let's connect. If there's any feedback, if there's anything that you might want to see more of, or you feel that I left out, or there's a gap in your understanding about DynamoDB, I would appreciate if you send me a message because I would love to make this presentation better. Yeah, sorry.
You had a almost metric of a real production data to show the difference.
Oh yeah. I would love to. You know what? That's a great. I will add that to. I'll add that to the presentation because Amazon has a ton of metrics on some of that. Yeah. Yeah.
First, have you had any problem with Dynamo tunnel consistency? First question.
The which one?
Dynamo tunnel consistency, right?
Yeah. So you do have. You can. Yeah.
Let me ask the second question. The second question is, have you tried Google Cloud Spanner?
I haven't tried the Google Cloud Spanner. So Dynamo does have some consistency things that I think we should I should have touched based on. So you have what you call eventual consistency, right? It's a bit different. So it's like a couple seconds or milliseconds sometimes from when you write, or if you update something to when you can read it. You can have a strong consistency, like a strong consistency read, and you can tweak that on the API. I think it's going to cost you a little bit more when you're having to do the strong read. But for the majority of use cases, the eventual consistency works. The other thing that I wanted to touch base on, and I didn't have a slide on here, is transactions, right? If you are coming from the relational world, we love transactions. It makes us feel safe, and they're great. And you have transactions in DynamoDB, they just behave a bit different, but you do have to give some thought to it. But majority of the time, you can get away without having to wrap everything in a transaction. But no, I haven't tried the Google product. Sorry, it was Google what?
Cloud Spanner.
Okay, no.
So last year, holidays, Amazon DynamoDB processed by 120 billion transactions per second. Cloud Spanner did 2 billion. It's fully relational transactions and everything.
Now, if you need 3 billion to handle 3 billion calls, my hat's off to you. You guys are going to close down on your seed rounding.
I'm just saying that because, like, I mean, I'm going to Google, so.
No, that's great. That's great. Nah, yeah. Hey, guess what? The best innovation comes from competition, right? It was somebody at Google that was mad. And yeah. So regardless, though, if you have that type of scale, hit me up. I'm curious. If you have billions of writes, go for it. That was it.
Right now it's just like a 2 hours and the next stock market and you can answer your questions.
Oh, yeah. Sorry. Well, I guess we have questions, but I'm going to wrap it up.
Like data warehousing and data engineering applications, or are they?
It's not made for data warehousing. Data warehousing, you're going to want to use relational, right? If you're running like analytics and like reporting, like a reporting engine, I would not put a reporting engine on DynamoDB. It's not made for that type of use case. If you're going to do like data warehousing, they have AWS has a product called Redshift, and it's made specifically for that. It's like analytics, data warehousing, but not. I wouldn't use Dynamo, but yeah. Serverless and like the other use cases. I mean, I wanted to expand the talk and show like how it works with Spring Boot, because Spring Boot has Spring Data, and Spring Data has a Dynamo project. I don't think it's maintained by the Spring Data guys, but the community does it, and it has some interesting approaches. But no, it makes it better. But at the same time, like they sponsor it, I think, or they're connected to it somehow. But you can use it and develop your CRUD type of application to it. Oh yeah. Oh, I don't have it, but
Just type in Andrew.
yeah, here's my name.
Are you a Han Solo?
Yeah, but you can look me up on LinkedIn by my name. I'm like the only angel who accounts here.
Yeah, I did the same thing. He's like the person that comes in, and if you connect with anyone else in the conference, there'll be a second connection anyway. So I know I don't remember where I got it, but I did.
Thanks for the chicken. Thanks for the Chick-fil-A.
My wife went and got breakfast. Oh, give me an 8 piece. Oh, they didn't sell 8 pieces. They only did 4, so I got a 10 instead.
Oh, nice. Yeah, thanks for sharing it. So right now it's like a breakout room.
You got the banners?
Yeah, I have the mic with me as well. Right now it's just empty, so there's nothing much to do.
Did you want to put the banner onto the screen?
What banner?
What says like, oh, boom cube?
Oh, okay.
Yeah, just to show people online. Yeah, next time. There you go.
Thank you. Are you going to be in this room? Like that. Are you going to go library?
I don't know. Maybe. But I gotta go help him on the stage.
So you use that here, oh, I think it's like a fully I'll actually running yeah. So our company is actually honored with, and so basically it's honored with, Because nowadays, I think in relations, Postgres is becoming better. Yeah, because it's free and everybody. So those things like hundreds like half the price, which is a very marketing. Yeah, they show that they are late. But the marketing side.
Hello.
Hey, are you over the shoulder?
Yeah.
How you feeling?
I'm feeling good. How are you?
Good.
Thank you for organizing. So far, so good. Everyone was having a great time. I talked with like random, other attendees. They said like they're having fun.
That's good.
Mhm.
Thank you for doing this and kind of giving back, man.
Yeah, and even in the chat, like people are like, yeah, this is like we got you working overtime. You're the person
Oh,
who's doing it.
yeah. See.
Yeah.
That's funny. That works though. All right, I'm gonna head back over there now, but I just want to check on you.
Yeah.
And you got water, so good.
Yeah.
Thank you, brother.
Mhm. Are you here for the Java? Are you here for the Java? So this you're doing the future. Yeah.
Yeah, that will be a contact.
Well, now you do. So, trying to everything right now. Okay, you just do it. I'm very happy. Okay.
Anyone here?
Okay. My name is
Oh, okay.
the next one.
Right, 130, right?
130.
130 is mine. So if you were
Let me
here
just-
at that time.
In 1:30, and you're doing the.
Let me write it down. So we'll be all this in this room only today, right?
Yeah,
This is A, yeah.
And you must be Cavasier for the Java Future Submission area.
Yep.
Oh, nice to meet you.
Of course. All right. What's your name?
I'll be wrong. Nice to meet you.
Nice to meet you.
Yeah.
And
All right. Here's your. Yeah. Oh, and this one happened yesterday, right? The future transient.
yeah, that happened yesterday. Yep.
Okay, that sounds good.
So
Yeah.
he had to fly back. I think he had a flight to Houston
Mhm.
and spoke to Danny.
Oh,
Then
okay.
we scheduled schedule.
And that's good.
And I'm flexible. I'm local here.
I'm also local here. I live in McKinney.
Yeah. I live in Freegrange.
Big ranch as well. I'll go and see
Where? Where exactly?
Heritage Bank.
Heritage?
Heritage Bank. It's near behind behind the Domino's at Region. Right ranch now.
Oh yeah. I'm on this Alma. So
Oh, like, are you? Oh,
I'm in the Liberty Hill.
oh,
Right.
okay, that region. Okay.
Yeah.
I think one of my friends lives there.
You have the Waters branch and Liberty Hill.
Oh, okay. I live near like Great Ranch now. So yeah.
Okay. But of course, like, we used to stay in a Stacy Crossing, Stacy Road as well.
Mhm.
Yeah. So I think like one of the first reasons, of course, out of many reasons, having Domino's and having Chipotle near. So,
Oh, Chipotle. Oh, Chipotle. Oh, you live there. Okay. Okay.
Chipotle is on the custard,
Mhm.
but we actually have this Colin McKinney Parkway on the Alma.
Okay. Yeah. Mhm. I think having an Aldi also nearby is very helpful, and your pharmacy as well. So yeah.
We have so many things, and
Mhm.
also like I actually go to temple a lot.
Yeah, my parents did this as well. Oh, by the way, I'm Adrian. I think we met yesterday.
Yesterday.
I think you were the person who told me to give like the speaker some suggestion.
Yeah,
Yeah.
she was actually keep on going on.
Yeah.
And what happened,
They gave us like a whiteboard.
so what happened is like she went the 8 minutes excess.
Mhm.
So the next person actually had to kind of like cut up.
The next person, I think he didn't have his computer set up. That's the
Correct,
problem. That's
they
why
were all right.
Yeah, that's the issue he had with.
Yeah. So because of that, right? So luckily we got saved. Otherwise, that you would have not had enough time.
Yeah.
I got 30 slides. Okay, I need to rush. I need to like go.
I think
pre-plan.
I think just be prepared by like 1:30 and you.
Oh
can,
yeah, I will be.
And also like I think on the intro slide you can have your QR code as well. So that way if in the end if people want if you might feel rushed or anything like that, people might not have the opportunity to connect with you.
I was gonna skip some couple of slides.
Okay. Yeah. Alright. I think I might be here, I might not be here, but like yeah.
Okay. All right.
Yeah.
I'll go catch up.
Yeah, thanks for stopping by. Okay, you share your screen, right?
Yeah.
Oh, I mean.
Oh wait, no, I didn't share.
Do you have the link?
I do.
Let me show you. Go to the streamyard.com/. Here's the code. What's the time right now? Okay. Please go to the following code. Streamyard.com.
Oh, not that one.
Yeah. The links might be this way.
It's 4 GR.
2GR4. Let me check again. Here, 2GV4. Okay, yeah. Yeah, it's GV4. Try again. Here's your mic, by the way.
Oh, how does Okay, hopefully that's okay. How do I see? Would you mind?
Did you log in?
Yeah, it's one in. I just want to make sure which one I'm doing. So I'm gonna allow this time.
Yeah.
Will it show me? Oh,
Yeah.
hello, hello, hello. Okay, display name is
I
like my
don't think
name.
I don't think this webcam camera. Yeah, just try to.
Oh, does it need this?
No, you
Cam?
don't need
Oh,
that
okay,
because we already have camera.
got you. So I'll stop that. I'll leave the mute. Unmute or mute?
You unmute yourself
Unmute. Okay.
because they have a
And display name. Okay. All right. In the studio.
mic.
Okay.
You can unmute yourself. Mute yourself. And please, like, you can share your screen.
Oh my goodness. Oh, slides or. Wow. What is that? Why is it a lot of feedback?
How about mute?
I muted this one. Oh, I mean.
No, I think it's.
Hello.
I'll contact someone. Maybe you can share.
Oh, it's a little dirty. Yeah.
You can actually go and mute on the computer. You can go and mute on the computer. Just.
Oh, do it from his. Can they hear me? Oh. Okay. Should I? Wow.
Hello.
In terms of board versions, one of the new ones.
Sorry.
What are the instead of putting T1, T2, and just guessing what it is or having to jump back to the top of the method to figure out what it is, I'm just going to name it intentionally. And that's a good practice. You should be doing that already. But I won't lie, once you have this verbosity that exists in your application, sometimes you just want to get it done, especially when you're doing testing. I don't want to write tweet, tweet, tweet every single time. Tweet, tweet, tweet enough. Like, I'm tired of that. Let me just put a T, let me put a T1, T2, and move on. But now we don't have to do that as much because we have this local variable inference. And it kind of flows more contextually nicely because I have a variable, right? And I have tweet because I've named it intentionally. Later down in the stack, I know that it's going to be a tweet because I named it intentionally. And the compiler is happy with this because it knows the reference type based on what's on the right side of that equal sign. And so if anything, it just makes your life a bit easier. And as you can see, build 9 is the greatest ever to do it. I don't have to worry about build 9 anymore because like my tweet is already established. And same thing for tweet entity. As long as you're naming your things intentionally, the local variable inference types just make things a lot easier to rock with. So just a couple of quick notes. The idea is just to reduce the boilerplate that you have to do, kind of like with, if anybody's familiar with Project Lombok, it exists because they're trying to reduce boilerplate, the getter setters that you always have to have there. Similarly, now with JDK, I think this was in 14 that it came out, you don't have to write every single reference type on every single declaration. You can just do a var and do your same old declarations that you're used to. And it was found that within the JDK, they can replace local variables, up to 94% of local variables with variable instances. And mind you, it does not mean every local variable needs to be a var. I want to make that very explicit. That is not what I'm saying. There is a style guide that was published by the JDK team that tells you exactly when it is necessary. They have 4 principles and 7 guidelines to make it happen. It's literally a step-by-step guide. They acknowledge all of the risks and assumptions that go with not losing that context of not having that type reference. So it's not a silver bullet. It will not fix everything, but it is important for you to know about because it can make writing code a lot easier for you as a developer. So let's see an example. Here we have a try with resources block. And notice in the top, and this is something I have done before, like I mentioned before, because you just want to get it done sometimes, especially if you're moving quickly. But we have input stream is, input stream reader, ISR, buffered reader, buff. And obviously on the right side, you know the exact type because you're creating new instances of those. Now, instead of doing that, because again, let's just say you're writing 5 tests and you have to replicate this 5 times. Sure, you can copy and paste it, but the idea for each test is that you're testing something different. So sometimes you have those nuances that you want to change. So going in and declaring it every single time can just get annoying, right? Not only that, but I haven't been diagnosed, but my attention span is pretty bad. And so when I see a lot of words, I instantly get, well, this is a lot. Okay. Like I like to just get straight to the meat. And so now with variable instances, you can just replace those. And with that, it forces you, like I mentioned before, to start naming things intentionally. So instead of IS, like what is it? I don't know. If it were later down the method, I would have no idea. I would have to go back to that reference. And God forbid it's a 1,500 line method that I have to jump back down to figure out what in the world it references. But now it's input stream. I don't have to jump back to the declaration to know what an input stream is because it's already named that. So if anything, it helps you as a developer write better code for those people that come behind you that won't have any context. Because the last thing you want to do is when an incident comes and you're having to go and try to explain things that you want someone to jump in with you and like know what's going on and you not have to handhold them the whole time. But let's just say the code is not being managed by you anymore. And you don't want the next person behind you to hate you, like just in another life because they're like, who is this Kavasia kid that put ISR? Like, why didn't he just write it out? That would have made life so much easier. And it takes 0 time to do. This will make you, in a way, have that done. Now, this is something I mentioned style guides because it is very possible for you to like set a new standard across across a new repo or any repo that you have. And you have an idea to just make things more succinct. And I put this up specifically because if you want to see the change, you have to be the change sometimes. My dear friend Ryan would always say that. And I'm learning more often that when you want to see that change, more often than not, you just have to be it. So if you were going to implement a new standard for your application, specifically on local variable instances, specifically around your own styling, make sure you're consistent with it. Make sure your team knows about it. Document it so people know. And that way they won't have any excuse not to, number one, know about it, but 2, follow it because it's already written, it's documented in code. And so they have no reason to not know about it. Oh, whoops. Quick little side-by-side benefits and challenges. Like I mentioned before, it reduces your boilerplate code. It encourages the potential of variable naming, which makes everybody's lives easier, even people who aren't developers. And then dismantle complex chaining. If you didn't want to do, and this is more subjective, but sometimes chaining can get a little confusing depending on what you're doing, like strings, for example. Sometimes if you want to break those down and connect those specifically to variable instances instead of trying to figure out what that method call actually returns, you can set it to a variable instance and again, intentionally name it so that way you can move on. If you don't take anything else from today, just remember the 4 C's for complexity, for challenges. Careless coders create complexity. Always, 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 always. We've seen it. I've seen it way too many times where people are just throwing stuff up and I'm like, I'm not approving that because I don't know what this means. And I should know, I'm on the team. So imagine if someone else, another developer were to come in and come behind you and say, I don't know how to make a change here. Well, they probably shouldn't be for the first place unless you encourage that. But also like another developer should be able to know what's going on. So moving on to the next one, we're going to get into pattern matching. So first, we're going to talk about switch expressions. With switch expressions were meant to simplify control flow logic, help with the scoping of variables, and then also release the traditional statements of switches from declarations and actually like to be able to return a value. And so you'll see in this first one, that break from dependency. We probably all, if you're a Java developer, you've probably all seen the standard switch statement. And one thing that always used to mess me up, at least, was I would always forget that break from time to time. So when that fall through logic that happens within switch statements natively, it would just miss me because we have a Monday, because you have so many different cases that apply to one thing. Sometimes you just want to return a value, right? And at least that's what pattern matching does. But the first step was to make it so that control flow is more succinct. And so instead of having like the fall through of having Monday, Friday, Sunday, you were going to return a 6. You would use this arrow label, which is new with the switch expression, and then you would just print it. And it makes it, if anything, and I'm going to say this a lot, reading from left to right in the English language is easier to see things because now you're doing your evaluations on the left side and then you're doing your executions on the right. And so you don't have to, it doesn't take as much time to see what's going on because it's directly laid out and you can quickly grab the context of what's happening. For case Monday, Friday, and Sunday, we're returning a 6. In case of Tuesday, we're printing a 7. in the case of Thursday, Saturday, and so on and so forth. Now, as this continued to progress, specifically with returning values with switch expressions, they are exhaustive. So in this case, I have to imagine, I think I took this from the JEP itself. And JEP is a JDK enhancement proposal. That's how new features end up in later JDK versions. But it returns this value, and I'm assuming this is an enum of all 7 days of the week. So in this case, every single day of the week is here, and that will come into play later for pattern matching, but I just wanted to mention it now. Instead of having to declare an object outside of your switch statement, you can have that returned directly from the switch statement, which to me matches everything else that you've done within Java, right? Like if you declare a new variable, you have your left side of your declaration, and then you have the new instance being created on the right. Similarly here, you have the assignment of whatever the switch statement is returning assigned directly to num letters versus you having to assign it in every single switch statement block that there is. And it just helps, again, with that control flow, you as a developer of reading it, but then also it's optimized specifically for switch because now it helps us set up for the pattern matching, which we will get into next. So pattern matching offers a lot for us. Number one, if you've ever seen, and I'll talk a little about this, I'll have an example later, but if you've ever seen that instance of pattern where you have a general object and you want to map it into, or cast it rather into an object, a specific type reference, then it does that automatically for you in pattern matching. So you don't have those nested if else blocks. We'll get into that a bit. It also introduces pattern variables. So that's where that casting comes into play. And then extensibility of your logic. Let me show you an example. So likely if you are a Java developer, you've seen something like this on the left side. And obviously this is a very complex case. Like it's not something that we want to do at times, but sometimes like it just makes life and extensibility a lot easier for you as a developer and the longevity of your application. But now with JDK 21, you have more opportunity for you to map these over in a more succinct way. And so instead of doing the object instance of that you see on the right side, now it was introduced within switch expressions to have that pattern variable. So that pattern variable specifically that pointer, that pattern variable right beside there's no lines either. Line 3 technically, that integer I, that's that pattern variable that you're able to use if it's scoped for that case statement. So in this case, what's happening is it's for that general object that's being passed in that formatter method. We're passing in, and then we're assessing each one to say, all right, object instance of integer, no. Okay, object instance of long, no. Object instance of double, it is, great. It's going to match that double now object into that D, and then we're able to use it within that if else block. Now you don't have to worry about that as much because with pattern matching, it goes through and it checks in more of a parallel way, and so it doesn't do it sequentially as if else. If we have a new object coming in, we can map it directly. And so what switch does is say, okay, does object match this integer? No. Does object match long? And again, it is done in a more parallel way. And so if it does apply again, it goes into that variable and you can use it directly on the right side. So it just makes things a lot easier. And again, this is exhaustive. And so it adds a bit of robustness to your application because you don't have to worry about the unexpected changes that could happen or the unexpected responses that you might have because it is exhaustive by nature, and your compiler will literally complain if you try to not catch all the cases. In this case, there's a default that obviously all the type references are not here, but there's a default clause to say, okay, if it's something that we can't cast it to, we'll just drop it and it's no big deal. And again, you don't have to worry about that explicit casting anymore because that was not a fun time at all. As an extension, there was also a time where we had to, it's not also a time because it still exists for JDK 8, unfortunately. But you have to check if you were to pass in an object, and Java loves nulls. Not really. Everybody has seen that the dreaded MPE exception being thrown around here and there. And to avoid that, we have to paint our methods with that if it is null, then we need to do something with it or just bomb out, whatever, like handle it essentially. Now with the switch statements, we don't have to do that anymore. It's actually built in. And so now we have case null and we can do whatever with it, whether it be throw an exception. In this case, we're just printing a statement. But now it doesn't have to be decoupled from what's already existing in switch, and it's built in. So once again, it makes reading your logic in a more succinct way a lot easier. And it's more efficient this way too, because now, again, you're running it all at one time. So if it is null, it gets treated just like the rest of them. And all the errors will be handled natively by the switch statement. Last example, once upon a time. Yeah. So there's always a case where, and again, if you're using switch statements, your application probably is a bit complex already. And so you never want to get to this point where you have cases or if-else statements within case statements. Like that's just nested conditional logic that makes it really difficult to know all of your potential branching paths that could happen. But it happens, and I understand sometimes it's hard to get around, and you just deal with it, right? And so in cases where you have your pattern matching, as always, and in this case we're mapping a string. Now, mind you, the input is a string too, so keep that in mind. But the input is a string, and on the if it does match to a string, assuming that it's not null, we need to do something else with it. We want a different response for every single one. In this case, we used to do if-else statements nested within, which isn't a fun time anymore. But now, with the improvements with JDK 21, we can do guarded case labels, where we have this when clause that exists on the left side on top of the case statement itself. And so what's happening here is basically effectively what that if-else is doing. The case is still checking for a string, so all of those would pass, but then only for that when clause would that right side of the block, the execution block, actually happen. So in this case, we check to see if it's yes, we check to see if it's no, and then if it's just a plain old string, we just print a sorry. The same way that you would have done with that if-else, but now again, we're keeping that evaluation on the left side, and then we're doing the execution on the right. So it makes reading your code, understanding it, and then also implementing it a lot easier. That could probably be a bit subjective for people. I think it's a lot cleaner this way because, again, you want to be able to code for people behind you, like not just for that moment and get your project done, because someone at some point is going to ask for a new feature that's going to have something else scrap it, and you need to anticipate that. So a couple of benefits and challenges of pattern matching. Like I said before, it helps simplify those nested conditional blocks. It's exhaustive, inclusive of null checks, so your code becomes more robust, and it helps reduce that redundancy and type safety casting. I had to mention some challenge. It felt wrong not to have something, and this was explicitly called out in the JEB, that sometimes with record patterns that were introduced in JDK 19, it's possible that the switch statement could bomb out abruptly, and it depends on how, for example, if you're calling a record pattern and you have an accessor method within that object, and it just does something silly. Like the example they used was like dividing by 0, which I don't know why you would do that. Can't imagine someone wanting to do that at any point because it'll never work. But that was an example that they use. Like it happens so infrequently that it's kind of silly to mention, but I felt it necessary to at least mention here because it isn't perfect. Nothing's perfect, but it will help you in several other ways to make your code more robust and easier to read. All right, last thing I want to talk about is virtual threads. And I think virtual threads are really cool. And I'm actually kind of sad because I haven't spent enough time getting to know them a bit, but I did a slight experiment to get going. Essentially, the picture does it a little. Oh, I don't have the picture. Sorry. Okay, I'll describe it a little bit. So basically the JVM uses platform threads because Java is a multi-threaded tool. And instead of having a platform thread, which are expensive and are limited dependent on your hardware, the JVM will create virtual threads per platform thread, depending on what your throughput is. And so the virtual threads are meant to be lightweight. They can be easily created and easily spun down like immediately. And the idea is that for applications that have non-blocking operations, you are able to continue to process things at a rate instead of having that one platform thread wait for something to respond back to and just wait. It spins up a separate Java thread, does a context switch, and it continues to process requests that are coming into your application. So let me show you what that looks like. So I use a tool called Locus, and Locus is a load testing tool, open source load testing tool written in Python. And I already had an application that's where that tweet block came from earlier. And I just wrote a small little Git API. And all it does is sleep for a second. And that is to mimic an intensive CPU operation that you might have, right? It mimics some non-blocking operation happening downstream. So the thread is waiting effectively, and then it returns the current thread. And that was the current thread name to back to you because I wanted to check to make sure that the platform thread was actually virtual versus a platform, and it does work, which is insane to me. And what I did, my test was to do 1,000 concurrent users. So effectively, every second, 10 users would get spun up, and those users would start hitting my application nonstop. And you'll be able to see that in the graph on the next one. Now, I did that for 1.5 minutes. So it's not even that long of a time, right? This was without virtual threads enabled. If you notice on the top side, I have requests per second that reached about 200 milliseconds. 200 requests per second. And then there's a 95th percentile and a 50th percentile. They were pretty close for the most part. But you notice right at about where that it started to reach that 200 requests per second, it started to have more latency. So this bottom, remember, I'm sleeping for a 1,000 milliseconds. And so sitting at the percentiles at 1,000 milliseconds makes sense because it should be pretty quick. All I'm doing is printing it. And then sleeping it and then returning the response back, which from the thread. So it should be very speedy. I'm not doing anything downstream other than sleeping it. And notice the latency started to go up at 200 requests per second. This is just platform threads. Check out what happened when I did virtual threads. That line remained consistently. And not only that, the requests per second continued to go up. And natively, Locust will notice that your application is starting to slow down. So it'll stop sending as many requests. And Locust noticed when I switched over to virtual threads, it was like, oh, you're handling this great. Like your latency is not changing at all. And mind you, this was only 90 seconds. So who's to say how long it would have been able to do this for? I'm not quite sure. But I think noticing that change already, and I think that was like within a minute, like just by enabling virtual threads, just goes to show how powerful they could be for your application when used in the correct way. And the funny thing is enabling it is as simple as a config change, which is the most, like, I could not believe it. And that's why I bid that print statement back, because I was like, there's no way it's that simple to just enable virtual threads. There's absolutely no way. But it is. It's literally a config value, Boolean, true or false. So if anything, it just talks about, it really emphasizes how much the JDK package has advanced itself. And it really wants to have specifically with Project Loom, have a stake within this concurrency, asynchronous processing world that we're starting to live in, because people want things now, and we need to be able to handle that high scalability, high traffic areas if we want to be able to compete in the markets nowadays. And that goes for any application or industry that you're in. So wrap up, I have a couple of references, just things I use. And obviously, Jeff, the Java team is awesome. Like, they always have previews up. Right now, they're doing primitive pattern matching for a release in JDK 24, at least they're saying it is. And then the long-term support, JDK 25, comes out next year in September. So things are constantly evolving. If you're not missing out on all these features, then you got to have that conversation with your manager to get it going. So that is all I had. Feel free to connect with me. I got my LinkedIn up here. And thank you. Let me cut this off.
Yeah, I think we leave it on the
Okay, thanks. Oh, I guess I didn't ask any questions about anything she chatted about.
So I don't have a question, but I'm a JavaScript developer, and I've never dealt with Java ever. And this new update, it's just like, oh, I was able to rate it easier. Oh, it looks like JavaScript.
Yeah. I'd say they're similar in that like simplicity in reading for sure. Java's obviously strongly typed. Like the wild west of JavaScript, I still have problems with sometimes, but that local variable inferences kind of gets into it. So that way it just becomes easier to write things. Like, that's one thing I do like about JavaScript. Like, you just declare const, let, like, and just name and run. Yeah. Literally, yeah. That's that's why TypeScript came in to give it some bounds. Yeah. So, any other questions?
So one thing I do, at least in my team, to try out these new features is to put it to the JUnit test cases. So that low risk, right? Everybody's scared of changing everything. So like especially when streams came out and this switch statements came out, it was like easier to say that, okay, this is something that we can do. Do you have other tips, like in a team environment, to make this transition?
I'd say like the biggest thing for our team was just testing. So we do hackathon projects where we just take like 2 days, and if we have a feature we're interested in, we just slam it. Like, we'll throw something in our test account, run load tests. Like I said, we use Locust at work. We use Gatlin. We're starting to get into Playwright too, and just like test the heck out of it just to try to mimic the current traffic that we're getting. And that way, if we're gonna make that transition, we're gonna start writing features for it, like we have some kind of POC and data to back it up, so that way we could tell it to upper management. So I think, yeah, taking the time to test, and if there's something specific you want to try out, like, yeah, give space for your developers to make it happen. That'd be good. Cool. Any other questions?
Have you compared your testing tool against something like K6? Have you seen K6? Is it similar?
No, I'm not sure. I don't think I've seen K6 before.
Grafana has a tool called K6 that we played around with a little bit for load testing. Just wanted to see what it was.
Is it open source too? Or
I think so.
yeah. Okay. I'll check it out. I'll keep a note for it. Yeah. Yeah. I was gonna show it because like the setup for Locust is super lightweight. I'm actually shocked by it. It's kind of similar to virtual threads. I was like, this is way too easy. Because I think the test already existed for my team before with Locust. So I was just adding on to it, but doing it from scratch, I was like, man, no wonder they did this. They love this stuff. It's cool.
We're so distrusting of things when it works immediately.
Tell me about it.
You know, there are times it
Right?
works, I'm like, wait, what's wrong?
What? No, seriously. Seriously. It
What
seems
is
too good to be
this?
true. Yeah. Yeah. Every time. Every time. I've been burned too many times, I guess. So, yeah. Cool. Any other questions? Sweet. Thanks, y'all. Appreciate it. Right on time. Stop. Did it stop? Did the screen share stop?
Yeah.
Okay, cool.
All right, let's go ahead and get started. Thanks for attending my talk on AI-driven observability. My name is Kyle Shelton. I'm a senior observability architect at Grafana Labs. A little bit about me, I'm a husband and a wife, or not a wife, funny story there. A husband and a girl dad of 3. That's twice I've done that, right? Yeah. I'm also an avid outdoorsman. I love to be outside. I go ice fishing once a year in Colorado. I'm a big hunter. I love camping. Kind of feral in that sense. I'm a bass coach, so I coach a high school bass fishing team, and I didn't, it's pretty cool that that's a sport now. I probably would have done a lot better in high school had I had a team to fish on instead of skipping school. Yeah, I love video games. I play FIFA, and I'm big into sim racing, iRacing. I love simulations, flight simulators. The mowing one too is a lot of fun. It's therapeutic to mow a big, space of grass. Also am a big fan of smoking meat. I can smoke a mean brisket or some baby back ribs. If we had an office, that was one of the things that I always would bring in on Monday, and I made a lot of friends. So it's a bummer that everything's remote now. But yeah, IMSA champion last year when I was working with TRD. We won the IMSA GTD Pro Championship, which was a big feat. That racing league is dominated by Porsche and Cadillac. So pretty big deal. Got a ring for it, and yeah, my career started about 15 years ago at Verizon. I was a network engineer. I bounced around a little bit, and then when cloud started getting popular, I got told that I need to learn how to get cloud certified, or I got to find a new job. So my career shifted from network engineering to DevOps and SRE. I did some SRE work at Splunk. I was a TAM at AWS supporting Toyota, which led me to Toyota Racing for 2 years, where I was a DevOps engineer and helped developers build fast, reliable software. About this talk, I want to kind of go over what our standpoint is at Grafana when it comes to AI. When it comes to AI, right? We're real bullish on the future of AI when it's applied to observability, as long as it's intentional, right? Our approach to building functionality is simple. We use it to decrease toil and to create a more gentle learning curve for the users and the practitioners who are using our tools to solve problems. And when you do that, it helps our customers understand, their systems better, right? And so that's what our approach is to this. And I'm going to go over some things that we have both on the open source and the cloud side to kind of show you how we do that. So let's get it started. Yesterday, Brandy talked about observability and logs, metrics, traces. If you're curious what observability is, the what is your metrics, right? Your counters, your percentages, those types of the things. That's what you use to identify what's going on or what's happening. Your logs are the why, right? They give you a lot better description of what is actually going on and why it's happening. And then your traces are your where, right? Where you find your latency, where you can see the whole path and figure out where the problem is. There's a 4th tier that's coming. It's called profiles. It'll be it's starting to evolve into the 4th tier. Profiles to me, and the best description that I've had so far is they're like your dashboard for your code resources, right? So like your dash in your car tells you your RPMs, your gas gauge, and all that. Profiles tell you where your code resources are being executed and stuff, so you can see it in kind of like a dashboard view, right? And so I didn't put it up there, but I did want to mention that's I would be shocked if it's not part of a 4-tier system, moving forward. So what are some of the challenges of observability, right? Well, the promise of observability is that it provides teams with the ability to maintain healthier and more reliable applications and infrastructure, right? But there's a lot more to that. There's some culture things that are involved, but getting to that mature state comes with a lot of really big challenges. If you're working at a company that has giant scale and stuff, moving data from one place to another is expensive and hard. Physics, gravity, you name it, the cost of moving data back and forth can get you. So it can be challenging. And then you also require deep domain knowledge and experienced engineers who can like find the root cause quicker. You know, you might have a team of SREs, but the one that's been there for 8 years has seen the same app break like 4 times. So as soon as they get that alert for that app, they're like, well, here we are again, you know, crash back, loop off, things like that. And so, and that you can't just like hire that on, right? That takes time, that takes domain knowledge, and it takes, you know, actually being down in the trenches to get that. And so, yeah, it's nice when you have those, but sometimes when you don't have those, it can be harder to, you know, have a good incident command slash SRE DevOps program. And then, you know, your engineers spend time on the toilsome tasks where it's like communication or parsing through logs. I can remember back in the day when I worked at Verizon and I'd do my deployments, I would have like 14 windows of secure CRT open, and I was just watching that tail-f, and I'd do my change, and then I'd be like, all right, which one, you know, where's the error coming from? There's a lot of tools now, but I mean, if you've been in the field long, you know what I'm talking about, right? Like tail-f, grep error, or grep bad, you know, whatever. So that's part of it, and that's part of, you know, proactively addressing anomalies, right? That it's really challenging, especially the more complex distributed systems you get, and it's really kind of tasks that humans are kind of not meant for, right? I mean, there are some humans that are really good at it in pattern recognition and stuff, but overall, I think that to me, like, okay, hey, I got error here, 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 here. AI seems like a good use case to be, you know, aggregate all of those, create a summary description, so when the practitioner comes in, it's like, hey, okay, you know, I got to do this and this and this. And even more mature is when you get to where you don't even need a human to integrate into that. You just have a workbook or a script that gets ran based on the error analysis, and boom, you have a self-healing system. So, why Grafana Cloud? Well, the AI that we have integrated really gives you a faster MTTR with an amplified experience, right? And that means that your ability to proactively transact and process things happens quicker. Faster MTTR, faster MTTI means better user experience. Better user experience equals happy customers, right? Happy customers equals more money for the business. So normally, you know, when things are breaking and it's taking a long time, or the customers are notifying you of the issues, you're not having happy customers, and that costs the business money. So if we can amplify and create a better experience for resolving these things, then, you know, we're gonna in turn save the company money. Less toil is also like something as an SRE, like that's principle number one, right? Like whenever I was an SRE and I came into a group of devs or an org, the first thing I look at is like, all right, what are we doing that is repeatable, that can be automated with a bash script? And so less toil, the better. And then the last thing is predicting issues. With the forecasting and some of the cool like metrics things that you can do, you can say, okay, we know on Black Friday we get our load balancers are going to get hammered with probably at least 2 to 10x more traffic. It could be more, it could be less, but we know if the past 5 Black Fridays that we've had, you know, we've needed to preheat like 4 more load balancers than normal Fridays or whatever. And so being able to predict that issues proactively is super important, and it's really nice to have outlier protection. For some of the AI and ML services that are available on Grafana Cloud and open source, here's a representation of that. To the left of the y-axis showcases the features that are available for open source, and then everything on the right is only on Grafana Cloud. So I always want to talk about that. At Grafana, we are an open source first company. You know, Grafana started as an open source project. The founder, Torkel, is still the #1 contributor of the open source project, so it's still very important to us. Now, one of the cool things that we have integrated into Grafana Cloud is forecasting, and I use this quite a bit. And I think it's really cool where you can better predict time series behavior. And you know, look at your historical trends to predict to reduce risk, right, and improve your efficiency. As you can see, you know, there's a kind of a bending curve, so you know that yellow line, you're going to be either above or below that, but you can kind of, you know, hone in on where you want to be within your systems. And you know, it doesn't matter what metric it is. That's very useful in my opinion. And as far as data sources grow, the machine learning supports Prometheus, Graphite, Loki, Postgres, Influx, BigQuery, Snowflake, Splunk, and Datadog. So you can use these on other data sources and backends, which is really cool. You can also establish dynamic alerts to more proactively address systematic abnormalities. So if I was going to set up an alert, I'd want anything that goes over that red line, right? And so whenever we start getting transactions or metrics that start popping over there, then you can get alert, because you know it might not be killing something yet, but that's abnormal behavior. And so if we have extended abnormal behavior, that might lead to an outage, right? And so using these kind of trends is really critical when you're dealing with observability. For outlier detection, this one's kind of self-explanatory, right? Like you got a transaction of everything going, and then whoa, you know, one picks up that. In distributed systems, that's been a thing that I've noticed throughout my career, that, you know, the black swan events or something can pretty much be identified if you're using machine learning stuff. So outlier protection is important. It allows you to spot when one instance in your cluster like is getting hit way more than the others, or, you know, outlier. You can set outlier based alerts. So like whenever that something happens, like I said, it might not lead to an outage immediately, but you can recognize like, okay, we're starting to see some weird behavior. Now we can be more proactive versus wait for customer to call because the website's down. I think Tim was talking about that with Tinder too, and how like it's all about the context. Just because it works doesn't mean it works, right? It might be slow, which causes a bounce rate, which means your customers are leaving your site. But nothing's down. So SIFT, this one's pretty cool. SIFT looks across all signals to find correlated changes. It doesn't solve the problems, but it really expands the search space. You can accelerate engineers to understand system behavior change, and it's accessible from on-call incidents and more, and even directly in Grafana. So it's a really cool tool. If you're wanting to look at something like this is resource connections from cube state metrics and slow requests from traces, you can kind of correlate more things, and you have more of a broader picture when you're looking at it. If you've ever troubleshooted something, you know, in these like high stress situations, you just got woken up at 2 a.m., right? Because something's down and you're on call, you get that pager duty warning or whatever. And the more broader of a canvas you can look at, the quicker you're going to be able to identify and fix the problem, so you can go back to sleep. So this type of tool really makes it better for the engineers, which, you know, as a former engineer, it's important. It's important not to burn out your SREs and your DevOps engineers or your on-call folks, because like when you're constantly working stress, your cortisol levels are raised, and you know you have mental health issues. You're not sleeping. It affects your family. Like it's important to not burn out by pager fatigue and stuff like that. So this doesn't have anything to do with that, but this definitely helps with viewing a broader canvas for troubleshooting your tools. And here is another part of SIFT where we're showing the detail on the error pattern logs using Drain. In this case, we've got a group of logs surrounding the KS services, and we found several patterns, right? Like the analysis found 4 of these patterns with significant changes, and then when you drill on that X error, it shows the exact log item that represents those patterns. So this is really a cool use case, because I've had those situations to where you look at a log and you're like, huh, that doesn't seem right, but it doesn't have like a warn or an error message, right? And then when you actually go back and figure out, like, that's the like camel or the straw that broke the camel's back, right? Like that event actually correlated to all of these failures later on down the line. And so when you can kind of group those together and then be able to kind of go through back and forth, it saves from the tail-dash-S madness. Pretty cool stuff. This is also only available in Grafana Cloud. Now, the dashboard assistant, let me go over here. This is a really cool feature, and I'll go ahead and play the demo, see if we can get this to work. But as you can see right here, we're in the Grafana just basic view, and you can kind of go through here, and what the AI is going to do is it's going to look at the dash and kind of give you a summarized view. So who here is bad at labeling things? Me, right? So this actually really helps. So when you're, you know, data scientist or whatever is building dashboards, you can kind of, you know, use AI to do that. That saves time. Like I can say about 75% of the dashboards that I've created have no descriptions. Because as soon as I create it, I'm like, why do you need a description? It's a dashboard. Just look at it, right? But you know, this helps those that are and that's something like I kind of want to get back to that, right? Like you have those domain knowledge from the engineers, the old grumpy ones that have been there, and then you have the new people that come in. This type of tool helps the new people come in and kind of, you know, create their own canvas for troubleshooting. I know I personally had specific things I look at and specific things I don't look at, and every engineer is different. And so the dashboard assistant, also available in open source, really helps the dashboard creation experience. And it makes them more robust and consumable. All right, go back over here. Oh, that's stuff the demo now. All right, and so the next demo I'm going to show is the incident auto summary. So have you ever worked an incident to where, let's just say like 4 different things break? You're going into the postmortem and you have to write a long essay about what happened, right? And you have to do this for your executive leadership because they're wondering, hey, we pay you all this money to make sure this stuff doesn't break. Why did it break? And so, you know, I've been in that situation. It can be cumbersome. It can be I get really anxious, especially when I'm writing things. I think Tim mentioned the critiqued PR. You know, that can be something I've been through an Amazon narrative review, and I don't know if you know the culture of the narrative review, but you basically write a paper about what you're about to do for your plan or whatever, and then you present it up to leadership, and it's like you know the Mike Tyson. You get, you know, critiqued and everything. So yeah, incident auto summaries can be painful. I know as an SRE, I hated doing them. I know they're very valuable and very important because you might go back and look at years down the line. So it's important that you get as much detail and everything as possible and you take them seriously. A lot of times you don't. Well, with this tool, you can easily do that, right? And so we're in incident IRM right now, and what you can do is you can select on there and then generate an auto summary. And what it's going to do is it's going to give you, you know, a summary just like that. So that probably, to write that out, probably would have taken me or another engineer at least an hour, right? Because you got to gather all your information, you got to write it down, you got to rewrite it, because when the first things that you know you write are never what you want to present to the executives and everything, and so on. So I really like that feature of IRM. I think communication is key, and the more you can document things too, like this will help the engineers down the line because it'll give you a detailed explanation based on the data, and so there's no bias, there's no human bias. It's as accurate as you can get. All right, and I did it again. We started it off. No. So, and anybody have any questions so far? No. So yeah, go ahead. Yeah, well, those are from demo content, and we just recorded demo content. But I mean, I'm sure they've definitely happened. I was just recording that to show how the tool works. Yeah, and so we can do profile analysis. Now, remember I talked about that 4th tier, right? And the profiles, and you kind of see the flame graph of how, like, you see everything, and it's all in one picture. Well, the profile analysis can also take AI, look at that profile, and give you a very sophisticated response back. And this is something that's pretty cool as well. And profiles, in my mind, are going to be the 4th pillar of observability. It's a little bit more cumbersome to set up. It's not just like plug and play like some of the Prometheus stuff is, but it's definitely the next step in, you know, monitoring and observability and having all the data points you can from your tools. The flame graph AI helps you understand the profiling data and using an LLM to assist with the interpretation. It also provides a convenient way to visualize the performance data, and these graphs provide a clear understanding of the resource allocation and bottlenecks within the whole application. So this is really good for app devs wanting to understand your profiles of the code that you wrote. the AI functionality in this, like I said, is very intentional. You're kind of getting at Grafana Labs. We're very intentional. We're not just putting like a Chat GPT wrapper in front of things. We're making sure that it provides value to the customers. And the next thing I want to talk about is asserts and how asserts helps with faster root cause analysis. So Grafana asserts allows us to correlate things across the board and prioritize the anomalies across time to understand the full scope, right? So within asserts, you get a single view to stare at the problem and stop and figure out how to fix it. You get to start at the problem. Sorry, not stare at the problem. You're not just going to stare at it and look at it and be like, what's going on now? You get to start here. And you have a lot of different options with asserts. On the next slide, I have BlackRock's talk from GrafanaCon of last year where they really dive deep in it. I highly recommend watching that. But the assert screen, like this is more of the flame graph, but you also have the star maps. If you've seen the star maps to where every single service is kind of looks like a spider web, right? And then you can kind of click in and then you see the full transactional process. It's really cool. And yeah, so customer story, take a picture of that and watch that talk. It's a really good deep dive on asserts and how asserts has helped BlackRock with, enhanced issue detection. They did reduce their MTTR, and at scale, they were able to minimize engineering toil out of the box too. It's really cool. It's a great tool. If I had a little bit more time, I would have done a demo, but I don't. I want to save some time for question and answers and get to the call to action. Try out Grafana Cloud free. Yeah, how's it going?
Oh yeah, no, you're big. I was just I was going to ask, what do you obviously in the system it doesn't know your system. So what do you use to train your data initially, and then how does it weight your system relative to the training?
I was talking about for the LLM, so we're already using pre-trained LLMs. I don't have an actual answer on the data that is used for those LLMs because I think specific parts of it, and then you also get to choose your LLM, so you get to train it on your own data on some of those features. But I can get back to you on that.
Yeah, because I was looking at that and thinking about also, how do you validate the reasonableness of your answer? So there's obviously metrics out there.
Yeah.
AI engineer.
Yeah, and there's an AI LLM app that is in beta still, and we're not like fully releasing that because there was a talk by Chris Marchbanks at Observability Con. If you look at it, he goes into detail about why we haven't gone like full all in on the AI and why like we're only getting to 75-80% results. In our mind, it should be 90, right? And because the data is so critical and everything. If you sync with me afterwards, I can get you that talk, but he talks about that and more and just goes into that. So yeah, but here's a QR code on getting started. The free program is really nice, man. It's got a lot they give you for free, and will be free forever. So check it out. Also have Discord. Grafana's GitHub page has a lot of useful resources. The community is awesome. It's a huge community, and there's, if you do want to do stuff on your own in the open space sports, you don't have enterprise budgets. There's a lot of ways you can get not the full Grafana cloud experience, but you can get a good observability experience if that's your jam. So, anybody else have any other questions? Yeah.
What was the difference between the profile analysis? What's the difference between that and tracing?
Tracing? Yeah.
It was giving the same information that like Tempo did.
Yeah. It's a little bit more expanded version of that, right? And it's at the ePBF level. So you're also getting ePBF. So yeah. ePBF is an enhanced Berkeley packet filter. It's like the networking layer of containers. And so it's, yeah. Very similar in the visualization aspect of it. Just cloud, yeah, just an IRM. That's the tool, Incident Manager. Yeah. Cool. Any other questions, concerns, comments? Awesome. Well, yeah, definitely send slides. I can share those. Yeah. Next with, yeah, and if you go back, I do have a LinkedIn link if you want to connect on my LinkedIn, my hi hello, and also has my blog. I do have a blog where I talk about DevOps, SRE, mental health, fishing, barbecue, anything I feel like writing about. So yeah, just whatever you feel. So, and that's a picture of me with Mr. Toyota. Funny fact, when we was in, I didn't know that was him, and I was just so excited. I picked him up and hugged him and stuff, and then I realized, like in our all hands, they're like, "Yeah, Mr. Toyota was with us," and I looked, I'm like, "Well, I'll be damned, he was." So, yeah, no, it was cool. It was a fun time. That was at Coda last year when Corey won. I was only at 2 wins, and that's the only victory lane picture I got. So it's very treasured. But yeah, thanks, y'all. Cool. Yeah.
All right, got that squared away. You're not seeing the screen? I'll share the entire screen otherwise. Okay.
Share screen. Share screen. Entire screen.
That's it.
Can you mirror? Yeah, go ahead.
Okay. Let me know if that's coming up. Okay.
So how to display settings? There's display settings. Go to Mars, go to base displays when it's in. Alright, good. Keep changes. Now go to the sharing. Okay, and then go to the Vineyard. You can share the right screen. Go ahead.
Yeah, got it.
Make sure you share the entire screen.
Let's see, Windows.
Do that one.
Yep, got it. Yeah, you should get it now. Thank you. All right. I prepared too many slides and I killed 5 minutes already. So I'll try to make it quick. So, cloud adoption at scale. My name is Santosh. I work for Cognizant as a senior manager. I implement cloud technologies and a lot of work on the AI and ML as well. So we'll keep going. I'll try to skip some of the slides in the interest of time again. So why is it? What is it? Why it is important? So I've been developing cloud solutions for a while, almost like 5-6 years now. And over a period of time, we always want to get to the next level. We want to start implementing the AI technologies, edge computing, quantum computing. We have a lot of things in mind. We really wanted to do innovate, scale, and do a lot of things. But the reality, majority of the times, right, by the time we get to a stage, we'll not have enough funding, we'll not have enough things, etc., etc. Okay, so started talking about this topic for a while, almost a year, in my office, in my company, everywhere I go. Okay, the reason essentially that we wanted to really do a lot of good things and a lot of innovative activities at the same time, right? We want to implement the projects effectively. Okay, so I'll give some real world examples what we have done over like last 5 years, right? First project we had like too many lessons learned. Second project we kind of shrink a little bit, but by the third one, right, we started kind of like implementing it much better way. So I just completed my fourth implementation about 3 months back. We scaled it to a level. It's kind of like a standard in a way, right? We have migrated the entire big data Hadoop to Databricks and AWS, and that saved us infrastructure cost of almost 8 million a year. And it's kind of like it's a big deal because like we are talking about huge data. I actually randomized like some of the numbers. I put asterisks, conditions apply kind of thing, because some of the numbers, right, I can adjusted not to kind of like disclose the exact number as such. So this is what we are talking about. So we have actually made a lot of savings, and about 15 plus terabytes. I made it as 10 terabytes data here. Okay, but we moved 10 petabytes of data, and we saw improvement. I'm talking about moving from big data Hadoop already. Okay, and I'm not talking about the legacy systems. Okay, we already have that environment fully optimized. On top of that, we can like made sure about 28% of additional performance improvement. The value proposition, I'll come to that later. This is kind of like why I'm getting into this, the weeds of it. Okay, so basically this is what we wanted to do. So I'll throw a question to probably every one of you. Hypothetically, right? Let's say you get 20% of additional funding for your project, or you have a proposal that you will be optimizing the project to save a 20%. What do you want to really do? Where you want to spend that money in terms of technology? Go ahead. Say it again. More headcount. And in terms of technology, where you want to take it forward? Example, like you might be doing a cloud project. Okay, we want to do something else with extra money. Innovation. Yeah. Yeah, quantum. Yes, absolutely. Absolutely. So I'll give an example. What we always think about it. Okay. So this will be very interesting. It could be like, I mean, like it might be eye opener as well. What is the excitement? Okay. The first thing what always happens is like, I mean, since I take care of the nitty gritty and the whole gamut of things in terms of starting from talking to the sponsors, program directors, everyone, right? So first thing we always go through is the project funding approval. It's kind of like a big deal before even get to the developer, right? We have to work in the behind the scenes, a lot of activity. So this is what we get to. Excuse me. So what we really want to build and design and build, etc. Okay. So this is what we want to build. This is where we want to start on the cloud technologies. And if we have more money, this is where I want to invest. This is where I want to kind of build more. If I still have more money, this is what I want to do. Okay. So this is our aspiration. This is what we really want to do. And this is the kind of like a challenge or real world scenario. What exactly that happens? We have the private funding done. So we have a bunch of cloud developers, cloud architects, all the chefs will come. They'll start coding. Okay. We do a lot of work. Alongside, we do a lot of things of this as well. Okay. So we have a lot of inefficiencies. How we actually can like keep on working while we are doing some migration. We'll go back to the inventory. We'll start looking at, hey, are we doing the right thing? So do we have the right design? We'll go back. Do we have the exact data governance process? Are we how be it our access governance process? A lot of inefficiencies. On top of that, we always have this number of meetings that we wanted to get out of, and the number of reports that we want to kind of escape from. So I'm not saying all of the money is going there. So that's it. It's a representation. Out of the 100%, 20% is what going into the inefficiencies. 80% is still being spent on the cloud. So I'll tell you where exactly additional money and additional inefficiencies will go. So this is another example and use case. Okay, I just put together some numbers. I ran into the Databricks and AWS calculators. I took the Databricks website as an example to come up with some numbers. These are like pretty close to reality. This is what the cost look like for a 500 jobs. I'm looking at that 250 terabyte of data, and if you're looking at the incremental size, it's not too big again. So, but we are looking at a monthly cost of nearly 35,000 for Databricks instance cost, compute cost, and also all of this, and even for AWS, right, EC2. We use it a lot, but it's the most charged for service. Like nearly 40% of our bill comes from the EC2, but still like the usage of it is barely to a certain extent. And this is the overall like monthly cost and yearly cost. I'm giving this rough numbers just to kind of like put it as a perspective. The size I took, the jobs, number of jobs, etc., way too small. And I work with clients where we actually do it like 20x, 30x of this number. So imagine where this is going. Of course, we'll have a lot of volume discount from the cloud providers, but still it gets to a point. The top number, right? Off late, since 2 years, we are factoring in two things. Previously, when we were in on-prem, we always used to worry about the labor cost, which essentially we talked in that terms like how many developers we would need, how many instances we would need, etc. Now, since 2 years, we started talking about what is our labor cost, what is our non-labor cost. So technically, to paraphrase that, right? How many developers, data engineers, and staff we need, plus what is our cloud cost, that has become the norm. So in on-prem, we had the luxury of like running any number of queries. Everyone had access, and we never bothered anybody running the queries, running larger reports, running it multiple times. It was not a big deal for us. But since we are in cloud, now everywhere, right, we have to do the FinOps. We have to keep controlling in every piece, and every time we have to keep watching about it. So that has become a big deal. Okay, so why I'm talking about this? So like I said, I work for a corporation where we implement a lot of cloud technologies. Of course, I'm not representing my cognizant here, but I came in individual capacity, but still, like, that's me. Okay, and what I do the cloud implementation, AI implementation, ML, and a lot of LLMs as well. So I do about like 20% of all the other great stuff, 80% on the cloud, predominantly doing the technical program management, solution architecture, etc., etc. So what we want to do as part of this, I want to give at least few takeaways. Let's fix this. Okay, we really want to go back to the previous slide and want to do those cool stuff of AI, the cool stuff on the edge computing, the like doing the real time streaming, etc., etc. And we want to kind of like do it within the available budget, available funding, etc. So let's see. Okay, so there's some areas, right? So probably these are some of the key takeaways probably we can actually look at. We can actually do the look at the key strategies, how we can actually migrate it efficiently, because most of the cloud adoption is starts with migration. Okay, then we will actually look at what are the better ways of like optimization, and what are the better ways of like value creation, etc. So these are some of the key takeaways we'll see. So in terms of the product roadmap and product journey, right? So these are the first two areas I want to kind of focus on. This is where the crux of the topic. In a way, the discovery phase and the design phase is what, if we do this correct, if we do it perfectly, this will actually lead the project to be done in a greatest efficient way. Okay, because all the time I see, once we are into the actual coding, actual development phase, we'll go back and start looking at the discovery phase items. We'll be assessing the inventory. Do we really need to migrate this table? Do we really need to do this in this way, etc., etc.? And once we do the right designs, right policies, right access governance, etc., once we establish all of this, the second two steps will be cakewalk. Pretty much like, I mean, they will be pretty much on the development side and consumption and optimize. In fact, I mean, I really want to replace this optimize with innovate. Okay, that's where we can actually get to. So how do we do this? So from here onwards, it's too like too much of nitty gritty, but I'll try to make it as simple as possible. Okay. So what we are looking at is like the very first step of the assessment or the discovery phase. So here, right, we'll go through all the inventory available. We'll take a look at it. What are the applications that we have, and what are the activities that we need to perform? What is our framework, etc., etc. And we already have a predefined the security and governance process, all the stakeholders, etc. And when once we get into the design phase of it, right, we carry all the available inventory. We'll take it forward. We'll look at all the inventory, ready inventory. We'll look at what is our strategy in terms of designing. Are we going to do the lift and shift? Are we replatforming, re-architecting, or doing something about changing the entire landscape of it? We'll make everything ready in terms of our inventory. Then, of course, we'll actually cascade all of our existing security and governance. We'll improvise them. We'll list out all the policies. By these two phases, we'll be pretty much done with the majority of the landscape of the project, program, entire piece. Okay. So the next two steps, they're going to be pretty easy, because this is where like the entire development piece comes into picture. So we have the curated inventory already. Now what we need to do is simply we need to start using them and start converting. So couple of interesting topics, right? What we want to focus is like we have a lot of accelerators available. Google provides accelerators, and a few other providers provide accelerators, and we have a lot of open source. We can convert majority of the code using these accelerators. convert the legacy systems from legacy ETL or legacy existing systems to Python code or a PySpark code or like to even PL SQL. We can do a lot of conversion there. And we have a lot of accelerators available in terms of the data validation. Those accelerators will help us directly generate all of the test cases. And also we can take it forward very efficiently rather than like spend too much time worrying about how I'm going to do it. A lot of accelerators will help us bulk convert the code. Since we already have the inventory information, since we have the assessment of everything, and we know what is the strategy, if we are ready to take all of this table, all of these data, or like some of this data, etc., because not everything fits the same size. Some of the tables, right, they don't need to be in the cloud. They can directly go into the storage, or like maybe the long-term storage like archives, glaciers, etc., because they are pretty much more of like a compliance data or like 7 years legal data, etc. They don't need to be transferred through ingestion process, etc. Once we get to this, right, the last steps essentially, right, so either optimize or innovate or consume. Okay, so this is where we'll get to. So most of our data, right, so we can actually do a lot of orchestration. In this way we can optimize this to an extent which is really really efficient in a way, right. A lot of jobs, they don't need to be running on hourly basis unless they really have a business need, unless they have a real-time scenarios. And a lot of jobs, they don't need to be running on real-time streaming all this. We need to kind of categorize what is really relevant, etc., and based on that we can run a lot of scheduling techniques. Okay, so I'll get to the next level. Just to kind of like keep it very simple, right? In a broad way, we see the optimization in two ways: one, a strategic one and a tactical one. A strategic one, right? We look at the 10% or 20% is what we could actually achieve with simple, seamless innovation using a lot of available AWS, GCP, Azure commands, etc. And when we are looking at the revolutionary one, right, we can actually look at re-platforming, re-architecting, and changing the CPUs to GPUs, etc. And the third one, essentially in the strategic, right, we can actually adapt the smart systems. We can use AI and the ML powered a lot of tools. Expensive, but yeah, that's kind of like one of the option. Tactical, this all can be done very easy. Tactical, we can go and implement them today. So probably with this session, right, probably you might be able to do most of this very quickly and do it. So the execution part of it, I'll keep it simple. So these are the areas we can actually simply go and do it today, right now. So the compute policies, the cluster policies, and the scheduling, all of these great things. These are the ones which will actually save a lot of time, a lot of money in terms of how we optimize our areas. This can be done very quickly and efficiently today. We don't have to wait for expensive AI tools to come and do it. However, right, I mean, there are a lot of things. Okay, so I just took an example, AWS example, just to kind of quote what are the easy kills that we have available. Okay, we have the compute, we have the cluster policies, etc. So some of this, right, I did not intentionally put icons because I actually see too many icons. I get lost of like how many icons I see every time. Okay, so some of the compute, right? So we all know this how we can actually do it, but I picked and chosen ones, some of the curated ones. Okay, not every, I don't want to go after every kind of AWS available service, but some of the instances, right, spot instances, I know like some of you use it a lot because we always pick and choose non-peak hours to pick the spot instance to make the cost very efficient. We always do that. We do a lot of auto scaling, compute optimizer. In fact, I mean, like I added a couple of the predictable ones as well, including the sustainability for the compute pillar and also the ML services for the clusters and also the data sync for the predictive ones. Okay, so here again, I actually kind of gave a lot more examples for each of the area. Okay, compute, cluster policy, storage, and visibility. Just to look at the color coding, right? The blue ones are pretty much available. You don't have to pay a lot, and the green ones are like AI and ML powered. They will actually make your compute go a lot faster. Okay, so this is too much to grasp. Anyway, I'll make these slides available on my LinkedIn somewhere, so you can actually grab all of this good stuff. And we do have a lot of practical execution, a lot of things that are going in. We can actually do all of it without spending additional dime, because these are already available in your cloud. If you're adopting the AWS or GCP or Azure, you might already have most of this available. So you can actually do all of this optimization very easily and efficiently. Okay, so what we are going to achieve all of this? Simple. I mean, like, so these are the 4 areas that we are going to achieve, especially the user experience, which is the most predominant one. Then, of course, we'll get the governance part, we'll get the incremental business part, rapid innovation. The top one is what my primary focus area, because anyway, we're going to achieve all of this. I really want to get to the last one with all of this optimization and building efficient systems, right? We will have enough time, money, and the performance on the system that will actually enable us on the rapid innovation. We can do a lot of accelerated AI ML integrations. That is very, very important. And we can actually make all of our cloud interconnected, and we can actually make it more useful for the open sources, etc. So I'll get back to the case study very quickly again. Not much change. When we have implemented this, we almost save like about $8 million a year by cutting down all of the infrastructures, all of the licenses, etc., etc. That's a huge deal. And previously, I used the asterisk. The asterisk I use is essentially, right, if you do it right, we'll save it. If you don't use it right, we'll start burning through very quickly. And that's again, I gave that example. So here, right, if we implement this efficiently, we might be able to do it much lesser than the $50,000 cost monthly basis, and much lesser than the 35,000, or much less than 85. So ultimately, right, all of this saved money can be used for our next activities. In terms of call of action, right, I'll keep it simple. So this is our picture. This is where we wanted to be, and this is our situation previously, and what we can do essentially, right? One actions, or at least 4 actions. Let's do the effective migration or effective adoption. That's one very key area. Let's do a very good assessment of our existing cloud, what we have already implemented. That also can be done. It's never too late. We can go back and fix. We can run an audit report. We can actually fix most of the inefficiencies. That's one area we can do. And we can actually do a lot of proven optimization. Some of them are actually provided in this slide, and I attached a lot of spreadsheets as well. This also we can do. Okay. And last but the least, when we move from on-prem to cloud, it's a big culture shift. Some old school technology users, they'll keep running their queries for no reason. They'll execute at the peak hours, costing us too much money. So we need to kind of train them, skill them, reskill them to get to a point to use it efficiently. Okay. So bottom line, right? So we have the funding. So what we want to accomplish, we really want to keep doing that. And in addition to that, I just want to kind of like get rid of the fire pit. I want to do this. And bottom line, right? This is what I want to kind of like get to the 20% of the money going in with our efficiencies. Okay. I really want to spend time on AI, really want to do all the streaming analytics through my Spark, everything. And I really want to innovate. And we'll get to that by using all of this. Okay. So why unicorn? So we cannot make our companies unicorn sometimes, certainly, but we can actually make our project as a unicorn. We can actually make our project as unicorn, and one such project everyone can actually strive to follow. Okay. So thank you so much.
Okay. So is it audible? I did.
Yeah, you want to keep that open so that the stream, live stream.
Okay. Okay, hi. My name is Shiva. I'll be presenting on safeguarding PHI in the AWS environment. I'm working as a senior cloud engineer in a company called Realtek. We process healthcare claims, what we get from the insurance companies. So this is based on the experience building our own infrastructure. So why we need to safeguard healthcare data? Because it's important data, personal data, and we are seeing the cybersecurity threats all over, and we just need to make sure that data is safe and we are securing it properly. That's true. I just didn't say that. So those are the stakes. Let's first start with where we're getting this data from. So typically when we go to the healthcare provider, we fill the forms, and also the providers will fill the forms and send this to the insurance companies. So either your company is handling this data from the insurance side, from the provider side, or some insurance companies send this data to some other vendors to actually process this data. That's where our company works. Data from insurance companies come to us, and then we process it and send it back to them. So this is the regulatory landscape. We need to be compliant with some laws, HIPAA laws. We also need to be compliant with SOC 2 and high trust rules when you are dealing with the healthcare data. These are different controls, just a list of them. So what AWS provides, AWS has several services which are already compliant with the HIPAA and all these rules. There's a big list of all the services that AWS provides which are compliant with this. Just these are the major services which people typically use, and something that we use as well. So before we start discussing, like if you are working for a small healthcare company or starting out a new project, that's the scenario we're going to try to go through. So where you need to start with is the basics. The basics is with the authentication. Make sure you have a single sign-on, multi-factor authentication, and you have a different users in your company, people who needs to access this data, infrequently access this data, or never need to access this data. And you can divide these roles based on the teams, based on their roles. Try to provide only the least privilege, least access that they need based access. And also you can also provide conditional access. There are different AWS resources that you can use to set up these. Primarily, for example, if you are trying to set up the single sign-on authentication, AWS has a feature called AWS Identity Provider, which integrates with any identity providers. And then you can go on creating the roles, and those roles will have all the permissions that you can provide to separate set of identity groups. So that's the first basic thing that you need to get right before you start thinking about different set of services. So we'll start going into major services that people typically use when storing the data. So one of the things that first comes to mind when we talk about AWS is S3, where it's object storage. What are the different things that you can do when you are setting up S3 buckets for storing PHI data? Make sure your bucket is not publicly accessible. That's a well-known thing. And if you are handling data for different clients or different insurance providers or different healthcare providers, some companies need that you use different encryption keys for all the data. So make sure you're encrypting the data, make sure you're using a different encryption keys, rotating your encryption keys and all that. And also one of the things that AWS provides is for the S3 buckets, you also have something called bucket policies. You can use these bucket policies to granularly regulate what people can do within that. For example, so this is one such policy. So what you could start with is completely deny everyone access, so nobody can access this data. So you would start with the deny policy, so nobody can access this data, and then you would go on to start providing specific access to a set of folders, and then provide what roles can actually edit the data, what roles can actually view the data, and what roles can delete this data. And if you are using something like a Terraform, based on our experience, what we have seen is these roles will keep changing, and you probably want to put it in a variable, and whenever a new role has to access the data, keep adding that, like keep editing that variable instead of going back to that whole Terraform module and changing the module itself. So that's for the S3 buckets and RDS. So same things again, basic principles. Make sure to encrypt your data. Regarding the authorization of accessing the databases, make sure you have separate roles for different use cases. Don't reuse the credentials, obviously. And then try to make sure they have different granular permissions for the databases within the instances, all that. And then when your service needs to access these RDS instances, make sure you are preferably try not to use database user ID password. Use something like instance roles when your service is running in EC2 instances, or roles, assign these roles to service accounts in Kubernetes, and then use that to access the databases instead of using ID and password. And if you have to use ID and password, put them in the secrets manager and use that. That's it. So you have your, right now we talked about having your raw data either in S3 buckets, your processed or raw data in the RDS instances. There should be a way for you to provide access to developers, especially when you are in a small stage, small company. More people needs to have access to the databases. How do you provide access to the databases or to your S3? So one of the things, especially very typical for healthcare data, is you want to make sure that data is not actually downloaded into your laptops. Then how do you access that? We want to open those files and look at them. One of the one of the services provided by AWS is AWS Workspaces. These are virtual desktops. You can have Windows, Mac, Linux, any kind of OS desktops. These can be integrated with your SSO, like Okta or some other authentication. With it would have a client within the browser, or a Mac OS app or Windows OS app, where you would download the data, look at the data, and then you can delete that workspaces again. So you are not actually downloading the PHI data into your laptops, like trying to keep it safe. And there are a lot of controls that you can put on these virtual images. You can put security controls over it so that nobody can actually download this data or upload this data from there. And then these workspaces can be restricted to specific VPCs, and then you can put policies on either your S3 buckets or RDS or where your data is, and make sure people are not actually able to download the data into their laptops and just into these workspaces, so they can download them, open them, do their work, and then you can maintain these workspaces to either remove the workspaces or do something like that. I probably stepped on the cable. Okay. Yep. So these workspaces have different types of instances. I mentioned you can configure the size of these instances. We have logging available. We can use all that to make sure your data is safe when people have to actually open and look at your PHI data. So this is another service. This is especially useful. We talked about scenario where your developers have to access your PHI data. Now again. Okay, sorry. Okay. It's gone. Yeah, it's keep. Okay. So we're talking about accessing the healthcare data, which is either in your S3 buckets or is in your RDS. So we talked about workspaces where you can actually download the data, look at the data, and make sure it is safe. So another place that you can do this is with Athena. So from Athena, you can actually run queries on the data in your S3 buckets, or if your developers actually directly want to access the databases, you would typically do that by having a jump instance in the network and try to access it from there. You could also have a database client within the workspaces and access it from there, or you can also do it from the Kubernetes cluster like a jump pod and then access the database. In all these instances, there is a possibility of either you have to provide the credentials or somebody accessing the credentials. You can also do it without credentials even there, but the Athena provides a nice interface within the AWS where you can only provide read-only access to the databases, production databases. They can run the queries. You can provide the, you have ability to granularly manage the permissions within the Athena, and all the communication is encrypted, results are encrypted. And then but if you are using Athena in order to directly access the database, you will start noticing that people will use this in order to create business reports as well. So make sure you are using read-only instances when you are connecting Athena to RDS, that's what we observe. I'm specifically talking about security within the EKS because that's more popular now. The things that you can do within the EKS is basic things. Start with the RBAC implementation, have different roles, link them to your roles that you have already created in the AWS IAM. Yeah, link IAM roles for service accounts. Make sure you are using the service accounts when you are accessing your data from the cluster. Like I didn't mention the obvious things, like make sure your data is encrypted, make sure your workloads are working, are all in the private subnets, all that. This is one of the important things that we need to like we are required to do when you are dealing with the healthcare data. AWS provides some of these inbuilt services for us in order to stay compliant. So make sure you are logging, all the metrics are available to you. You are monitoring what's going on with your workloads, what the people are doing within your organization. Compliance again. So you're not just for the business continuity, you're also actually required to keep the data, whatever you are provided with when you are dealing with the healthcare data. So make sure you have the versioning turned on. People are unable to delete the data from the S3 buckets. AWS has this nice service called AWS Backup Service, which can be used to back up databases, S3 buckets, and all that stuff. So make sure you're using them. Put your backups in a different region. Maybe we have gone through an instance where we accidentally deleted a database, and fortunately we had a backup in a different region and were able to put it back. Yeah, seems obvious. Yes, have incident response plan. Have people who will like. One takeaway would be run through scenarios where you are, even before you see some kind of an incident. Have a scenario like role playing incident where you would go through an incident and then see what role people would be playing. Like go through each point of time, like when you detect an incident, declare an incident, start recording the all the major events that are happening when you are going through an incident, how you would recover from it, reporting about it, have a plan for that. So that's where we go through incident response and preparedness.
There is a separate team for it.
We do. It's hybrid. Like there are a couple of people who are dedicated to do this, but even the SRE cloud team are also involved. I think it's typically that's how it's done. There will be people who are dedicated to doing this, and there are other people who are expertise in handling the infrastructure and all that. They also need to be trained and involved in these training sessions and all that. That's it. Any questions? We are a small company, small team, but we're awesome. If you're interested, that's our company name. You can connect with me. I can recommend you.
About the your data. What type of data are you
It's a healthcare data. It comes with your name, your address, what health conditions you have, what kind of procedures were done on you, what kind of claims you, yeah, what kind of claims are going to the insurance companies, all that data. So everything that's associated with the patient, all the procedures done on it, everything regarding that. Yep. Yeah.
Oh, yeah, I mean, so not just profiles, but like diagnoses.
Yep.
Like charts and stuff.
That's all.
Okay, good afternoon. Is it my mic? It's muted. Okay, good. Thank you. Okay, good afternoon, everyone, and happy to see so many technical faces in these 2 days. And thank you for joining my session as well. It's been afternoon, and we had so many great sessions from the beginning about so many technologies, cloud, programming languages, and so many things. So I'm also going to talk a little bit about enterprise integrations in the cloud, and also how efficiently and effectively you can develop enterprise applications in the cloud using the ballerina. So when you hear the word ballerina, you might wonder whether I'm going to talk about something related to dance. It has some relationship with the dancing, but not exactly. So it's a new programming language, comparatively new programming language, or rather a platform that I'm going to introduce. Before diving into the session, let me quickly introduce myself. I'm Anupama Patrage. I'm working as a director and head of engineering and DevRel in the a company named WSO2. If you haven't heard about WSO2, it's a large open source software development company, specifically in the domain of API management, integration, identity and access management, and so on. We are in the industry more than it's almost 20 years now. And so I'm representing WSO2 as well as open source community related to Ballerina. So that's about me, and I'm also based in Austin. I was started my career as a C++ engineer, and now a little bit deviated from the development paradigms because I'm leading the development efforts, but still I love coding and I'm a developer still, at least certain percent of my time. So that's about me. So let's start with the discussion. This is something that I generated from AI. This is very easy to generate these kind of things with AI now. So you can see an application developer here, and his typical work is like developing application, but you can see so many things in the background, so many complexities. It has so many deployment options, cloud, data sources, connectivities, all these things. So that is kind of a typical application developer's uh, status as of now. So sometimes you might want think, okay, we don't have to worry as developers about where we are going to deploy or what sort of complexities, data sources. It's kind of, you might think it's not relevant to the application developers, but the reality, it's not the case. And even in the cloud world, it is connected. So you have to, as an application developer, you always have to think about where you are going to deploy it, at least to certain extent. The reason is that's what we call journey from code to cloud. Application development start with planning, and then you have to design the application, develop it, build it, test it, and finally deploy. And towards the latter part, we heard so many great stories about monitoring, operational level stuff, and so on. And iteratively, with these insights, we have to plan the or improve the applications again. And where you deploy your application, it really matters, whether it's in the bare metal or VM or cloud-based deployment. All these things matters because at the end of the day, you have to think about the seamless integration, how you scale your application, and also reliable deployment strategies. So that's why we say you always have to think about those aspects. So the cloud integrations or cloud deployments are comparatively easy, but there are so many inherent challenges with cloud deployments as well, because cloud means you naturally involves numerous services or APIs. You have to connect with so many things. They must work together, and the environments are so dynamic, challenging. And with containers, you have to think about different levels of layers of complexities with several microservices, and also configurations. How do you manage the configuration, scaling? And if you are writing the YAML files, cloud deployment files manually, it's also kind of headache. How do you manage them? How do you write them? It's again, you have to learn how to write those things from the scratch. And also security and compliance. That's also something that we have to think of. We heard great session. We had so many great sessions today about how do you deal with security in the cloud as well. So those things you have to, as a developer or as a DevOps person, you have to deal with all these things. So today I'm introducing Ballerina, a technology for simplifying cloud integrations. So let's first talk about what is Ballerina, just to understand what we are going to talk about. It's an open source thing, first of all, and it is optimized for integration. If someone asks what is Ballerina, I would say it's in one aspect, it's programming language, and on another aspect, it's a full framework. So it's developed by WSO2, which is the company that I'm representing, starting 2016, and we released the first version in February 2022, which is what we call Ballerina Swan Lake version. And it took a couple of years or few years to develop because it's a full programming language. Developing a compiler and all the full ecosystem around that, it took time. And also it is a rich ecosystem with different data services, support for data formats, connectors, and some differentiation factors like the textual representation. If you are familiar with programming language, you know there are so many textual editors that you can work with. And similar to that, all of these, we have as textual editors. And apart from that, we have graphical editors as well. I will come across those things later in my slide deck. And also, then the first question comes is, why do we need another programming language? There are so many programming languages in the world, and why we decided to develop another programming language or rather framework. And there are so many different reasons. Let me go one by one in upcoming slides. But in simple word, it has so many rich ecosystem, and it's easy and efficient when it comes to integration application development. So it's so much optimized for the problem domain of integration. So that's a little bit about the history. Let's talk about how it differs from other languages, or what are the similarities as well. So it is more than just a programming language, and it comes with the same family of syntax like C, C++, Java. If you are familiar with any of these languages, learning Ballerina is not hard, and it's a general purpose language. That means if you write something in Ballerina, if you write something in any of these languages, you can write it in Ballerina as well. But the difference is, if you are writing integration applications, it's very much faster, effective, and less number of codes, and so many advantages. So the reason or how we are doing is, we provide different levels of abstractions in the syntax level as well as connectors, so many other things. And also we provide so many tools as well as graphical representations to support all these things. And it's built on top of existing technologies, and it's not a research product. It's used by many open source community users as well as WSO2 customers as well. It's an open source. That means anyone can freely use it. WSO2 involve if you really want to buy support for that, but as open source users, anyone can use it without any problem. And we do release patches and updates frequently, so open source users can heavily rely on it. And there are no two separate versions as open source version or commercial version. It's the same version. It's additionally WSO2 providing support if you are willing to have production support on it. So I told that we provide different set of abstractions. I can categorize those abstractions into three levels. First thing is data, how we represent data. Because in the enterprise, in the integration applications, data plays a key role. Because when we are integrating with two different applications, what we are doing is we are communicating data. That means we have to accept data, we have to transform it, we have to manipulate, we have to communicate in different data formats, different types, and we have to do certain calculations based on data, and so on. So that means we have to have easy mechanisms to represent data. In Ballerina, we have Java, XML, those things as inbuilt data types, and transformations and manipulations of all these different data types is very easy. And the network, because integration applications means we are talking with or we are interacting with network. So then you have to deal with clients, you have to deal with services, and you have to write client or services applications as well. And it can be many different protocols. So Ballerina has intuitive syntax to write all these different client services and all these protocols in all these protocols. So that's the next level of abstraction. I will show some code examples so that you can understand later. And then the third thing is concurrency. integration applications are inherently concurrent. That means you will get concurrent requests in integration applications via network. So that means you have to deal with concurrency without any doubt. But the problem is when you deal with concurrency related issues at runtime, it's typically very difficult. If you have ever debugged some concurrency related issue in runtime, it's very difficult to tackle. But in Ballerina, we have compile time warnings or compile time suggestions if you are having some data races. That means if you are accessing some shared data, or if there's a possibility that your code run into some concurrency related problem in the production or runtime, then Ballerina compiler itself can detect it and give you suggestions, warnings, and things like that. That means as a developer, you can fix those things while you are developing the application and then be done with that. So those are the three different aspects, abstractions, and then let's talk about how the full life cycle would look like. First thing is the development, because we start the application in the development phase or the design phase rather. So in Ballerina, we use familiar tool set. It's not completely new thing. If you are familiar with VS Code as a IDE, Ballerina has VS Code plugin, and it has both visual capabilities as well as typical textual capabilities as a language. And if you are familiar with, if you want to store your source code in any of the source versioning systems, you can have any of them because it's a programming language. And the build systems, you can integrate with anything. Deployment, you can deploy it anywhere, serverless or Kubernetes environment or whatever. And if you want monitoring, it can connect easily with any of the monitoring platforms. So that means once you build the application, it can easily integrate with any familiar tool sets you are having. So just to get some understanding, what is Ballerina? So when you go to ballerina.io website, you can download the Ballerina packages, Ballerina installers to be clear. So this is where you can download it. It is just installed one time. Once you install it, you will get a CLI command tool as well. And you can update your Ballerina versions using that CLI once you install for the first time. You don't need to download installers for each and every version upgrade or each and every patch release. It will handled by the CLI tool itself. Then after that, it's just a matter of creating a new project using the CLI tool. So if I show you how it looks like, let me create a new directory. If you issue the bell new command, because the bell is the CLI tool, you can see Ballerina is already installed in my machine. And when I issue the bell new command, let's say hello world, I use the -t service part as well, because let's say I want to develop a service. So I just issue this command and the project is created. So if you issue if you analyze the files, you can see a couple of files got created. And if I open it up, this is my first Ballerina project. So you can see this file got created. It contains couple of files, but if you look at the .bell file, that is the source file where you write your application. You can add many bell files as you wish, and there are some package concepts as well. You can add modules like you do in Java, packages and so on. You can organize your code if you write complex application, but this is very simple one with one file. And then once you have it, you can simply run it. You don't need any other container or anything as such. You can run it using the bell run command or using this code action. And there's try it option as well in local environments if you really want to try it. We have try it tools as well. Now application is running. Let me close this window and try it. This is simple hello world program. You can, let's say commit your code conference. And once you execute it, you can see hello. This is simple hello world program. So this is how it looks like, just to show that the language nature of it And these are the other supporting files. Ballerina toml file is a file which identifies a given package as a Ballerina project. It includes the name of the organization and name of the application, version, things like that, some metadata. Other things are like very much VS Code related things. So that's how we create a Ballerina application as a first step. So that is the language nature of it. You can feel that it is very much similar to any other language. Then, so this is what I explained already. Then it comes the visual parts. So usually the first thing that we do in application design is to design our application, or at least the skeleton or the APIs when it comes to integration applications. If you are developing a service, let's say REST service, you need to define your API, like how others would interact with your application. That's a REST API. So Ballerina support this visual stuff where you can use your visual editor. So let me open some already developed. That's again a simple application with just having one file. But you can see here we have a service. So here this service is, the service syntax is part of the language itself. Once you attach a service with the listener of certain type, that service become a service of that type. This is a HTTP service. For example, if I write another service on GraphQL, let's say test, and on port 9090, that becomes a GraphQL service. So writing a service, we need to fill the remaining parts, but writing a service in Ballerina is very simple, and even running it simple, testing it simple. You can write many different types of services, HTTP, GraphQL, these are different types of services, and if you really want to use different protocols, services or clients, that's very much intuitive. And the good thing is these are the abstractions that I mentioned, because this, you don't need to worry about underneath complexities. Still, if you want to configure so many other things, we have the ability by providing additional parameters here, additional security or other related stuff, but it's very much abstracted out, so that you don't need to worry too much, and it looks like the normal programming language concepts. For example, this is a resource function. This is where you accept incoming request. It looks like a normal function. This has 4 resource functions with the name albums, and it returns certain types, and also it has certain keywords to say whether it's a get request, post request, delete, and so on. These are the common HTTP words. So once you define this skeleton, it's just a matter of writing your business logic. So in Ballerina, we support visual aspects as well. So if you look at this, you can see, you can overlook what your application looks like. Since this is just one file, you might not see some lot of things, but when you have, let's say, 20 files and 20 different things, many different data types, many different services, many different resources, it's very hard to understand what is going on. But with this visual designer, you can see Swagger like view, and you can even design your skeleton of your application here. You can add more resources here. You can define your path parameters, response types, and so on. You can define, add new, let's say, test without any parameters. You can see new resource got added. Likewise, you have to fill this business logic later, but defining the application skeleton is very much easy. Whether you are a seasoned programmer, then you can, if you are a seasoned programmer, you can use the visual side. But if you are a typical integration developer, who is very much familiar with the low code stuff, then you can use the graphical design side as well. So that is about the visual aspects of the service designer. Then once you run the application, I already ran the Hello World application, but it is the same. You can use bell run command here. Simply, it will run the application on this port. It will run. You have to go to the project root and issue the bell run command. Once you do that, it will start the application, and you can invoke these resource functions. So since this service has base, this is how the service is defined. This has some errors. Yeah. I added GraphQL. Yeah, let me rerun it. You can see how the service is defined. It has slash here. That means the base path of your application is slash. And then you can see this is the albums. That means, sorry, I think I'm running it already. Let me run again in different mode. So you can define, let's say this is music store. Then if you say slash music, then you can write it in, run it on slash music. Likewise, it's very easy to run your application and you can try it. So it's same as this. So these are some of the warnings that I mentioned, concurrency related stuff, because there's some shared or global level table which is accessed by all these resources, which can lead into concurrency related problems. That's why the compiler is giving these warnings. So that's one aspect. And then the other thing is GraphQL Service Designer. This is one thing I wanted to show. This GraphQL Service Designer is again showing you another interesting aspect. If you are defining a GraphQL application, you can see how the different services, resources are interacting with your data graph. This is your data graph, and you just have to define the records and this will come up automatically. You don't have to do anything. If you have the VS Code plugin installed, it will come up automatically. Either you can define things in the graphical level, or if you do it in the code level, you can see it nicely. And the other interesting thing is, when you write, if you write any piece of code in Ballerina, you will automatically get a corresponding diagram for that. That is inspired from the sequence diagrams. Usually in integration applications, you are interacting with many services, many applications. So here, when you look at the code, it might take a little bit time to understand what's going on. But when you look at the diagram, you can see it's connecting to GitHub, connecting to G Sheets, get some data, process it, and things like that. And even you can add constructs from here, and it will update the code. So it is, you can see that if condition added here. So it's we maintain the parity between the text and the graph visual side. So you can use whatever the familiar or convenient side to develop your application. So those are some things about language and the visual aspects. And this is one other thing, the data mapper, where usually when we get integration applications, we have to convert data. We have to manipulate data. We have to transform one type to another type, like JSON to CSV, JSON to XML, CSV to JSON, things like that. So we can easily do that using Ballerina. This is what we call data mapper, and we can map the functions or lines. It's just visual drag and drop, and you can add some calculations in between expressions easily, and it will you can generate the same thing in the code like this, but it's sometimes it might be much easier when you have a large payload to map or convert. Data mapper is much more convenient. So those are some visual capabilities. Let me go back to the slides. So this is GraphQL design I talked with, graphical view, in-sync documentation, data transformation, and debugging. Since it's a programming language, debugging comes into the picture as any other usual language. You can debug easily. And we have support for almost all the protocols. You can write any of these applications, services, clients in any of these protocols. And apart from that, we have sophisticated library for several functions like time, cache, all these util related stuff. And also we have 6,600 plus connectors to connect with different SaaS applications, ecosystems, databases, and so on. So it's very much easy. And also persist. This is also another feature that I didn't show in the VS Code, but if you're familiar with ORM like features in other languages, this is almost same. You can see entity relationship diagram automatically generated out of the source code. You don't have to do anything, and it will come up. You can persist without understanding the underlying data source, whether it's SQL, in-memory data store, Google Sheet, whatever. You can persist without writing exact queries or the data source related application logic. And there are so many other tools. For example, OpenAPI tool, healthcare tool, and so on. Let's say you have OpenAPI specification. Then what you can do is, using the OpenAPI command of Ballerina, you can generate the Ballerina code automatically. And also, if you have the Ballerina service already, you can issue the OpenAPI command and get the OpenAPI specification so that you can share it with other collaborating teams. and also testing capabilities similar to any other language. And AI support we recently introduced. We have GitHub Copilot support if you have the GitHub Copilot already. And also we have inbuilt as AI assistant to generate unit tests, documentation, and so on. And the automap feature to map the data types automatically using the data mapper. And when it comes to deployment, what we usually generate is a .jar file. But let's say you want to deploy it in Docker. Then what you can do is you can go to your application. I'll quickly show it without taking much time. If you issue bell build -- cloud equal Kubernetes, you will see the relevant Docker files and Kubernetes artifacts will be generated in the target folder. Right now the target folder is empty. Now you can see the Kubernetes and Docker related artifacts are generating. I think I need to connect to, yeah, something's going wrong. But anyway, you can see the Kubernetes and Docker. If the command running correctly, you can see the Docker and Kubernetes artifacts within these folders so that you don't have to run your application or write your Kubernetes artifacts specifically using the using manual methods. So yeah, that's about Docker Kubernetes stuff, and you can have serverless AWS Lambda or anything else. And when it comes to observability, we support open telemetry. It's observable by any open telemetry tool, and it support matrix tracing, login, and everything. This is using Grafana, some example using Jaeger, and distributed login as well. So when it comes to the Ballerina advantage, so I talked about some capabilities. So it's close to your problem domain. So if you are writing integration-based application, you can do it with any language. But if you are using Ballerina, it gives you so many abstractions. That means less time, less number of codes, very easy to write, and maintainability is high because you have visual aspects. You can understand the code easily without going through each code line. Diagram will give you so many capabilities, and also API documentation comes automatically, and so many protocol support and production ready connectors, and also Graal VM support is there, so that memory footprint and startup time is very low if you are compiled with Graal VM options. And also the important thing is it's open source and free to use. So I'll finish my discussion by introducing you to the Ballerina community. We have very active community around us. We do tech talks, trainings, university programs, hackathons, and so on. We recently finished Hacktoberfest in the October month. We, I think, gave around 10K worth gifts who contributed to our repositories. All the source code is free and open source, and we conduct so many sessions with students and a lot of communities. And if you are interested in having any sessions, it's not purely about Ballerina. We teach them common concepts, common stuff, and language theories, compilers, and everything, because we went through that journey for many years. Even if if the community is interested about learning how we develop the compiler, we do certain workshops and sessions like that. So if you are interested in, you can join ballerina.io/community. You can see the details. And we have certifications as well, all free. You can join and do them. And there are some resources to learn about the language. And also you can contribute and win prizes as well, because as part of open source initiatives, we started doing hackathons and so many events. So if you stay tuned with us, you can join all of these things. So thank you so much. If you have any questions, feel free to ask, and please connect with the Ballerina community, as well as this is my profile. Feel free to connect with me as well. Happy to see you all in the community if you are interested. Thank you so much. Any questions? If not, feel free to join with us.
I would like to present one of the most paramount and critical topics, securing multi-cloud and hybrid cloud environments. Basically, this is all about my experience or the period of time that I worked with different clients. So I'm going to talk about what are the best practices we're going to take consider in order for us to secure the environment. So about me, you can find me on the LinkedIn. That's the QR code you can scan. About me, I've been in this IT field for over 18 years, as I mentioned, specialized in cloud architecture, security architecture, DevOps, and AI and ML. My personal hobbies, obviously, talk about the different technologies, architecture, cloud, security, automation, doing some blog writing articles, and teaching the students and mentoring the students, mentoring the people who needs the help on these technologies. Apart from that, my hobbies are hiking, blogging, coding, playing cricket. Whenever I get a chance, I used to go and play cricket with my friends. That's all about me. Okay, let's dive deep into the multi-cloud environments. So what does it multi-cloud environments would look like? Multi-cloud environments allow the organization to choose their own cloud. You have to best fit the service. Some of the services are good in AWS, some of the services are good in Google, some of the services are good in Azure. So picking the right services and the right solutions is very important for the organization. Integrate those solutions and security for those solutions. That's the key factor. So understanding the services, understanding the layers between these services, and how you can secure these multi-cloud environments is very important. And also, you don't need to vendor lock. If you don't like this particular service or vendor is not doing good, then you can always switch to the other vendor. Here you go. My experience, most important piece to be successful and secure the environment is to understand the architecture of the systems. What is the business goal? What is the business system that you're handling it? How does the application needs to be built? And how you want it to, how is your infrastructure to be built? And how can you secure this infrastructure? And when you have one service is running another cloud, and you also have another cloud running another service, how do you integrate that security? Talk each other. How do you maintain the standards? When it comes to the hybrid, as you see, multi-cloud utilizes multiple cloud providers to enhance service offerings and avoid vendor locking. Hybrid cloud environments, what do you mean by hybrid environment? Combines private cloud. Some organization like fintech, they don't want to buy expose those services, or they don't want to use the AWS, or Google, or public cloud providers. Rather, they would like to build their own private cloud to ensure that systems are secure and they're building their own platforms. So allowing that flexibility and workloads and data management, that's the key for this organization. I think the next generation, couple of things you see that so many trends going on the edge computing, quantum computing, and also how do you ensure the security of these systems, and how you maintain this platform hybrid environment, like building your own cloud, building your own infrastructure, making sure that you follow the security standards. And third important layer, as you can see, the flexibility and resiliency. Organizations always can adapt to changing needs and improve reliability and leveraging diverse platforms. When I say diverse platforms, so always you do not have a single solution for every scenario. One of the example I can talk about that, one of the students in the recent when I was presenting one of the sessions, so he asked me about I know this service, I've used this service pretty much, and this is pretty cool service, I think this beats everything. No, that's not. Nothing cannot be it. You need to understand the business. You need to understand what exactly you're going to do with that, and then take that, what all things it is happening, whether this particular service can be integrated with any other service securely, and are you following the zero trust, like as you say. I'll talk about that in detail. So you should not be trusting. So as you can see, a lot of incidents happening, cyber security incidents across the organization. Protecting the data is very, very important, and securing the environment is very, very important in the industry. Alrighty, next one. What are my strategies to the customers when you want to secure your environment? Security challenges in multi-cloud and hybrid cloud environments. You need to understand the key security challenges. One other thing is complexity. How complex your systems are. Most of the systems, you see that some of them running in different, you could have the application running in different languages. Some use Java, some use .NET, some use other Python, etc., etc. They build all these services and expose these services and use those tools. And the complexity of the platforms, understanding that complexity. So increasing the complexity is always tend to be manage the environments. It's pretty challenging for any organizations to manage these environments and secure these environments because of the complexity that it provides. So any misconfigurations that leads to a lot of issues. I'm not going to talk about incidents happen. There are many incidents across the globe happened. So because of the misconfigurations, and we also have seen so many outages by the cloud providers. So that's all happening because we don't maintain the standards, we don't maintain the exact real policies, and you're not protecting every single data. Okay. So data breach, as I said, data breach is more, it's toughest for any organization that the data gets breached, then you lose the credibility. So you do not want to do, you have to protect the data. How do you protect the data? You can layer those data, protect those data in a different manners. So layering those data, I'm going to talk about that in detail, how you can layer and structure the data based on the classifications. So when I say classifications, you can classify the data as public. If you think that data is public, yeah, well and good. You can share the data, no issues. If you think the data is business sensitive, you always have to think about how you're going to protect the data to the business stakeholders. Apart from business stakeholders, it should not be seen by anyone. If you think that data is confidential, that means that confidential data is for that company, whichever the company it's going to be. So the confidential data, how do you going to protect those data is very keen. So I'm going to talk about that in detail. Next slide. Another one is compliance, maintaining compliance across various, this is going to be the challenging thing. So you might have seen many organizations talk about so many training. Especially if you are in banking sector, you could see that you have to mandatorily complete this training to understand the compliance, whether you are following the compliance standards, etc., and all those things. Why? Because the awareness of the platform, awareness of the critical security incidents happening in the world. So you don't want to get into that. So that's the, how do you govern and regulatory policies for different organizations? How do you ensure that the compliances are met? So if you look at that, outside of the US, we have Europe, GDPS is one of those compliance. You need to maintain that. And also SCI classifications in the banking sectors. You have to follow the regulatory requirements to satisfy your environment, etc. Everything you build. Yes, so I will talk about that detail. So these are all very, very key, and the compliance are paramount. You have to maintain that. If you are not more than 80% or 90% of compliance, then most of the clients not willing to take you as your one of the vendor. So compliance is very important. Visibility, you have everything, but you don't know whether there is an issue or incident happen. You always need to know every single action being performed by every system needs to be scanned and monitored, and your monitoring systems are developed in a way that, okay, detect the solution, detect the problem. This is what I see that somebody is trying to access the site. I think most of them are developed here. So you all know that different attacks, DDoS attacks, SQL injection attacks, how do you want to protect them from the web applications, right? So you can build a web application, firewalls, etc. I'm not going to talk about that. I'm only talking about the mechanics and the standards and the best practices that you can build to protect your entire end-to-end systems, both multi-cloud as well as hybrid. So the monitoring is very important. You need to integrate that monitoring. You can use different tools. I'm not going to talk about the tools as well. There are a bunch of tools. There are people who have talked about Grafana and others, observability, Splunk, Dynatrace. There are many tools you can use it to make sure those are integrated. So what is that integrated? So you can, best thing I could say that all these assets are being tracked. So you need to have most of the scenarios that you see in the ServiceNow can be integrated with all these asset management in the cloud as well as the on-premises. So you have every single data being stored in, being tracked in ServiceNow. You can integrate that with the security platform that you choose, whatever the tool it's gonna be. Tool is not the important. The standards are the important. How you are utilizing those standards and protect your data as well. That's all about. These four are very essential to be successful, and the challenges that you see. What is effective security strategies? Anyone talk about unified security policies? Have you heard about okay, I think most of them might have used AWS cloud. So have you heard about the guardrails, guard duties, SCPs, protect, and how do you track the events that are happening, like CloudTrail? You can integrate those systems, etc., etc. So so creating these policies, you don't see maintaining these policies in different places always be a tedious, because you do not have unified solutions that creates the policies. What policies? Security policies. Implement, it's always be consistent to the business. What is the business that can tolerate that? I talked about the data classifications. If you think that the data is public, it doesn't mean that you're not going to secure the data. But you can allow the data to the customers and outside of the customers. And what policies you're going to implement, how you can secure it. We can talk about that in detail. There are many ways you can do it. If you are in microservice architecture patterns, so there are many services that offers like Selenium and Sysdig and Tigera policies. You can implement those. I'm not going to talk about the tool sites here, but the techniques that you can use to build it. So unified security policies are key for effective security strategies. Another one is the encryption. How do you encrypt the data at rest? What do you mean by data at rest? Okay, I'm going to store the data, whether it is in database or in the disk or anywhere. So you need to encrypt the data with your customer key, whatever the technique you're going to use. Let's say AWS as an example. AWS is a service called key management service, or you can bring your own custom key that is only built by the organizations, and then you can create, make sure that data is encrypted, and you create the security policies, the boundaries. security boundaries. Where does that the bound is coming from? So you already have unified security policies for the business. So those boundaries are aligned, and also the data being encrypted at rest, encrypted in transit. Second one, encrypted in transit. Whatever the data that is being, you have the service to service communications. Make sure that the service is communicated securely using the right ciphers. There are many ciphers. People talk about different ciphers. What does it mean, cipher? Like TLS, TLS 1.2, TLS 1.3. So what exactly that does is, behind the scene, ensure it uses the different ciphers, cryptography, and make sure the data in the transit is always be encrypted. So you're following the best latest protocols to make sure the data communications, data at rest is clear, So that is always be the case. Whenever you see the latest version of the ciphers, TLS 1.3 is the default one that everybody is using it, because the hackers always think about, okay, what all things that have been secured in the systems? What do I need to do to get into those platforms by trapping those algorithms? So in the organizations, that's the reason why, so vulnerabilities, understanding the patterns, how these data is coming. So security is very important, and always have to update to the latest that is available to ensure that your data is secure. Third one is multi-factor authentication. Why I'm saying is, you might be using different systems in your platforms. You need to ensure that the data is, whatever that device that you're using, or whatever the services that you're trying to connect to, you have to enable the multi-factor authentication to ensure that it's not only protecting your data, but also it ensure that the additional security measures that you're taking. So multi-factor. These are the three effective security strategies that you can adapt to maintain the security. Let's talk about, that's all about, I talk about this in detail. I can give you the scenarios. I can go more in detail based on the questions you have. But hybrid security, picking the right model. So for example, you have systems that are running in both cloud as well as the on-prem. So you want to connect the data to the cloud, to the on-prem. All the data communications should be encrypted. Then obviously you need to ensure that the integration of security tools, how these data, and then the segmentation of the data, segmentation of the policies, segmentation of the networks, and there are other layers. Like, you have to consider all of the layers: network, and then data, application, etc. So you need to ensure those are generated. I can give you an example. One of the client, the hybrid solution, they've been asked to provide a connectivity network between the AWS to the on-prem systems that are running. So I want to ensure that the end-to-end encryption in place. So you can, if you look at the AWS, you can use Transit Gateway is one of those services, and to connect to AWS to on-prem direct connect gateways. That may be enabled in direct connect gateway. You have MACsec enabled, which is a latest feature that direct connect gateway that offers. So that gives you the make sure that the transmitting of this network is secure. You can also build your own routers, Cisco routers, etc., and ensure that the data in transit and the connect peers between the services are, all of them are encrypted. So it all depends on, I'm not going to talk about the tools. It's all about whether you are trying to follow the right standards to ensure the isolation of the segmentation policies, network segmentation, network policies, and then have the firewalls implemented to detect the any unauthorized access between the services from AWS to cloud, cloud to the on-prem, anything. And you need to make sure regularly audit. That is very important. Conduct regular security audits to identify identity access and vulnerabilities, ensuring the systems remain compliant. So how do you audit that? There are many tools available to automatically detect the data, but there are very, very tiny services available to prevent that from happening even before that you detect, right?
I thought you had to pay $50,000 for a third party. That was
Yes, that's good. So third party auditors, you may that's a good question actually. So I'll tell you what, you may recruit a third party auditors, give your best review the whole environment, provide your feedback, constructive feedback, I would say, to ensure that the organizations can follow that. These are the problems that you see. You need to ensure that you have to abide those things to fix those problems, and then your environment will be good and audit compliance as well. So these are the strategies that works, that has been working, and there are places to enhance it as well. So these are the strategies that we need to think about it and how we can secure the hybrid environment. Here you go. Best practices for data protection and compliance. I talked about data classification. Classify the data based on the data that you classified. You ensure the data is followed, and you also have access controls, implement strict access controls and permissions to limit data access. And third one is regulatory compliance. Add to the compliance that regulatory, depending on the sector that you are in, you need to follow the standards, regulatory, SOC compliance, SCI compliance, GDPR, etc. So, IAM solution. First thing you always see, anything you integrate, identity access management. So, importance of IAM solutions are, it protects the multi-cloud and hybrid environments. So, any authentication and authorization that happening, you have to see how that can be leveraged. Like you are trying to connect to the platform, is a legitimate request. How do you validate that? Okay, I authenticated, it looks good, but I need to authorize that service, whether he is authorized to perform that action, whether it's going to be GET or push or post or whatever it is, if it's an available application. So, and you can even, I talked about how to protect the data, like firewalls, web application firewalls, and then the different next generation firewalls. When I say next generation firewall, it will make sure the complaints are met. You follow these standards. So IAM is one of those key. So you have to have role-based authentication enabled. Most of the security incidents happened for the past couple of years because one of the secret key has been exposed. Why do you need to maintain a secret key or an access key? If you follow the role-based RBAC, whether it is on the application side, infrastructure side, or Kubernetes or microservice or whatever you do. So if you are creating RBAC, rollback policies, access controls, then obviously you don't need to maintain those secrets because it generates those secrets short-lived credentials, just speed up the session. Once the session is expired, then you're done. They don't even see that secrets. You don't need to expose yourselves, right? Yes, keys are done. So that sort of solution. So single sign-on is one thing. When you logged in, okay, you already logged in as a customer. So obviously you are integrated with that customer. You authenticated that pretty good, nice. Then the rollback access controls will be validated and ensure that the rollback policies are met, and you're good to go. Okay, I have authenticated, I got the credentials, I can see this guy is authorized, I'm giving him short-lived dynamic credentials, then you can access the system. So that way you can protect the, this is one of the technique, and this is the standard techniques most of the organizations are following, and it's working technique, right? We always have to advance the solution. I'm not talking about different tools. We have different services. We have ForgeRock, Okta, and all of them. I'm not even talking about those tools. You pick whatever it is, whether you follow these three, good to go. Talked about the last in the compliance, and the monitoring is one of those, right? So effective monitoring and response. How do you monitor the data and assessment those monitoring? And one of those monitoring is key incident management, incident monitoring. You have to respond to the incidents, etc. And there are many examples I gave in the previous discussion. So this is one I can share you the slide if you guys need it. And the strategies I talked about, there's unified security, robust data protection, advanced IAM solutions, and learn real world case studies, safeguard cloud environments and hybrid environments. These are the key pillars that you need to think about it. And if you would like to know more about it, feel free to connect with me. I can talk about that more. Thank you all. Huh? Thank you. Hope you guys liked it.
Thank you.
Was it, man?
Good.
Yeah.
Thank you so much for your time.
Yeah. Hello.
ఒక స్లైడ్ కార్డ్ మీరు మొత్తం రోజు మొత్తం గడిపించేస్తారు మీరు.
అంటే మనం రియల్ గా చెప్తున్నాం కదా, ఫేక్ గా చెప్పట్లేదు కదా.
నేను అలా ప్రిపేర్ కాలేదు. అలా కంటెంట్ పెట్టుకుని తెలుసుకున్నా, అంత అవసరం లేదు, నాకు అర్థమైపోయింది.
No need to content, because examples, real time examples, and explain. Even scenarios దగ్గరికి వెళ్ళకుండానే నేను explained every single point where that is. Oh my goodness, sorry. Thank you. Thank you very much.
Okay, here's your mic. You can hold it or put it on your phone.
I got to get into the StreamYard.
Yeah, sure. You don't have the link on hand. Just go straight to StreamYard.
Yeah, StreamYard. BX24N2GB4. No, we're good. Yeah, he just had it written down really big.
Share your screen.
If I need to switch back and forth with tabs, I'll be able to do that, right?
Yeah, if you share the entire window, share the entire screen.
All right, let me do.
To present.
Why did everybody get so quiet?
Talk.
Make us loud.
So down at the bottom it says present.
Listen, bud.
3 minutes late. Share.
Yeah, let's do the entire screen. Whatever. Yes. Fancy. I'm done. Yeah. Thank you for coming to the talk. It's pretty sick, right? You let me know when we're good, man. Check mic 1, 2. UFOs are real. How is everybody doing? Good. Has anybody ever seen me give a talk before? No. Ooh, yeah, a little bit. Y'all are in for a treat. Can I move around, or do I got to stand here like a bump on a log? Oh. All right, I won't move. I'll try not to move. I like to move. I like to move. I like to move. All right, so we got 25 minutes. I'm the last talk of the day in this room. I might stay for a little bit longer. I don't know. It depends on how I feel, right? I'm a little tired. I came from Vegas. I was at reInvent. I've been traveling all week. And we're here at Commit Your Code. And I don't know about you, but Danny and team has put on an amazing, amazing event. So huge shout out to Commit Your Code. I want everybody to applaud so they can hear us in the next room and over. So on 3, 1, 2, 3. All right, I love it. Thank you to Commit Your Code. This is the official hashtag for the event. So if you are on Blue Sky or Twitter, it will always be Twitter. It will never be X. This is the hashtag that we are using. This hashtag was trending yesterday. So we are kicking butt and taking names. Let's keep that going to the end of the day. We want a year 2. You let Danny know we need a year 2. He's not going to want to hear that, but we need a year 2. So Commit Your Code is the official hashtag for the event. I also would love for you to use this one too. If you follow me on Blue Sky or Twitter, anytime I talk about the developer community or anything dev related, I guess you could say, I always use the hashtag developer community. Just a good way for me to track the engagement, see what y'all are doing if we don't directly follow each other, right? So if you are on Blue Sky or Twitter, if you could throw hashtag developer community on there, I would appreciate that. This is me. My name is Chris DeMarge. You can catch me on Salt and Burnham on Twitter, chrisdemars.net. On Blue Sky, I'm also, I knew they were going to get a hold of these files. So this information's been redacted. Just kidding. I'm a senior developer advocate. I work at DigitalOcean. Is everybody familiar with DigitalOcean? And you love DigitalOcean? Yes, you do. You love DigitalOcean. Get out. There's an exit right there. We are like your one-stop shop platform as a service company. In this demo, I'm not trying to sell anything, but I am going to be using App Platform and DO to deploy this app. So we're going to have a little fun doing that. I also believe in cryptids and Bigfoot. I also believe in ghosts. And everybody is here to learn about UFOs. I also believe in UFOs, UAPs, and USOs. So one question I love to ask everybody, does anybody believe in UFOs? Right? Yeah? Okay. What about ghosts? Bigfoot? Other cryptids? Mothman? Mothman is my favorite cryptid. Straight up. Chupacabra? The Fresno Nightcrawler? I can keep going. We can keep going. We can keep going. Dogman, Beast of Bray Road, we can have a lot of fun. So we're here to talk about UFOs, UAPs, USOs, and the like. But first things first, the talk is called Close Encounters of the Data Kind, Exploring UFO Sightings with MongoDB and Next.js. But first things first, like I was saying, I do want to talk about a little bit of UFO, UAP history, sightings, and abductions, to kind of lay the framework for what we're going to be talking about, what we're going to be deploying, and how you can take the data that you get out of your books or even ChatGPT or that you're researching online, compiling that together, ingesting it, and then being able to deploy that to the cloud with just a little sleek UI. Does anybody remember July 1947?
I was there.
You were there? Okay. I thought that was you, Mac Brazel. So 1947 was the official Roswell incident crash. It happened between June, July-ish. Something, we don't know what it is. We might know what it is now, but they keep that secret. Something crashed in a field in Roswell, Mexico, about 17-ish miles away from Mac Brazel's ranch. He went and he discovered a bunch of foil type things. It was pretty gnarly. Called the Air Force. Air Force came in, sectioned everything off. One of the pieces that they found that they were considering a weather balloon was a foil. And this foil, you could crumple it up into a ball and let it go, and it would go back to its original shape. It was extremely malleable. It was one of those things, but this was a weather balloon. So that kind of sets the context for this. July 1947, Roswell. Is anybody familiar with the Betty and Barney Hill story? 1961. So Betty and Barney Hill, first documented abduction case. The story goes that they were coming back from vacation. They were driving back to their house in New Hampshire. They saw a UFO. It kind of went away. They kept going down the road a little bit. It came back. Barney got out of the car. Next thing they knew, they were back at their house, but their watches didn't work. They lost track of time. There were imprints all over the vehicle. There was a weird chalky type stain on Betty's dress. And what makes this even cooler is that something presented Betty with a star map. Now, Betty is not a ufologist. She's not a physicist. She's not someone that studies the planets in the star system. Something gave her a map in her mind of a star system. She drew it out. It was given to a couple ufologists, and it was mapped perfectly to the Zeta Reticuli system. So they say if you ever hear about grays, the grays, they're from the Zeta Reticuli system, or reticulans. So that's really interesting. There's a great book called Captured. It's about that thick. It's in my paranormal library. Really, really great book. There's a documentary on Discovery Plus too about the Betty and Barney Hill story. So if you check that out, it's pretty sweet. And then I want to talk a little bit about this one. This happened in Dexter, Michigan. By the way, I'm from Detroit, Michigan. If you couldn't tell, go Lions. We had a great game last night. Sorry, Green Bay. March 20th, 1966, something was sighted in Dexter, Michigan, which is close to Ann Arbor, if you know your Michigan geography. And if you don't know your Michigan geography, Ann Arbor and Dexter are right over here. I live over here. That's how we do it in the Midwest in Michigan. They brought in J. Allen Hynek. If you're familiar with J. Allen Hynek, he's a physicist, ufologist. They brought him in, working with the government, and he turned around and said, oh, it's just swamp gas. And everybody believed him. Well, it came out years later. A lot of people that saw the sighting said this was not swamp gas. There was something abnormal, unidentified, that we could not explain, but it was not swamp gas. So, a little backstory on three kind of big sightings and abduction stories. There's a bunch of them out there. You got the Rendlesham incident, and you got the Zimbabwe incident with the Ariel school kids. Tons and tons of cool stuff out there. I'm sure you wanted to hear about all that. I wanted you to hear about all that. It's hard to turn a 45-minute talk into a 25-minute because, like, that stuff matters, right? I'm a big proponent of history before you get into the meat and potatoes of what you're trying to talk about. But let's talk about the tech. So this app that I built, it uses Next.js. And if you're familiar with Next.js, it's a React framework for the web. It's pretty sweet. Built-in optimizations, dynamic HTML streaming, React server components, RSCs, route handlers, server actions. If you want to use it, this is the command you run in the terminal. npx create next app at latest. That'll pull down the latest version of Next, and you can start just building. Next up, we're going to be using Mongo, one of my favorite databases to use, because it's not really relational, not really at all relational. It's an object-style type of database. There's key value pairs, JavaScript really in the middle, right? That's pretty much what it is. It's one of the world's most popular document databases. This is directly from Mongo's website. Jesse did not validate that, so I'm sure he will. He's probably, of course he is. So it's document model, so it's pretty cool. Flexible schema, so you can move stuff around. Distributed and resilient. It horizontally scales, which is pretty cool. And then, last but not least, we're going to be using App Platform on DigitalOcean. And if you're familiar with DigitalOcean, like I was saying, it's a cloud for the whole entire journey, from everything that you need to do, right? We just recently, a few weeks ago, dropped our GPU droplets. So if you're in the AI ML space and you wanted to check that out, we have that to use. They're running on NVIDIA hardware. We have our managed database services. That's what I'm using in DO, is our managed Mongo database service. We also have Kafka, MySQL, Postgres. We have OpenSearch. It's a fully managed product as a solution, product as a service solution. So I can take a website, deploy it to the cloud, boom, I get a URL. You can take a custom domain, map that to it, kind of like you would if you were using Netlify or any other deployment platform. You can use whatever you want, right? It doesn't matter to me. I'm not here, like I was saying, I'm not here to sell this to you, but it's what I'm going to be using because it would be a little awkward if I tried to use AWS. for this talk. Spaces object storage and block storage, that's pretty cool. You can take a lot of data, especially like images, documents, you can store it in the cloud that we offer, and you get a custom URL for that, and you can use that in your databases or if you're trying to serve up any images. And then we have our own Kubernetes offering called Docs, DigitalOcean Kubernetes. So if you're in that space, you might dig that. And with all of these three powers combined, we are, that was a Captain Planet reference. Oh, Captain Planet. With our powers combined, no. With all these things, we are going to take some UFO data, build out a UI, be able to deploy that to the cloud with a little bit of material UI mixed in, just to style it pretty quickly. This is what it's going to look like. It's just a very, very baseline type of UI card system. You got your cards here. There's a search, so you can filter the search, just a header, and then at the bottom, there is a footer that says Built with Love by DigitalOcean. So if you want to do this and you want to use the Mongo version of the Next app, this is how you do this. This is installing the Mongo integration. It's this right here. It's npx create next app -- example with MongoDB. That way it brings in all those Mongo dependencies, and you can just name it whatever you want, right? This mine's Close Encounters. Have that open, run it in VS Code or Sublime or whatever your text editor or IDE of choice is. Run it in the terminal, CD into that, npm install all the things. Hopefully you got good Wi-Fi, and then npm run dev, spin that up on localhost, and you'll have your next app, and you can start playing around with that and working on that. And we're also using Compass. So I'm using Compass to hold all the data. Has anybody used Compass before? Cool. So Compass, it's a free interactive tool for querying, optimizing, and analyzing your MongoDB data. Get your key insights. You can run queries. You can run AI queries. It's pretty cool. This is what it looks like. And like I was saying, it's a document database, right? So you have your key value pairs. You can add stuff to this. You can run various queries. You can have all your different databases here that you need. It's a really, really good way to hold all that data and then be able to bring that in to whatever platform that you're using, like if you were using DO. We also have to build a database. So this is how you build a database or set up the database in DigitalOcean's app platform, the Cloud Console. If you have an account, you go in. We have databases on the side. Create your database. This is a cool tool, by the way, Screen Studio. I love it. You can select your data center. We'll just leave it for New York. We're going to choose Mongo. And then we are going to go down basic. You can choose the different types of paid services. You can change the name of the cluster so you can keep things organized, because if you just leave it default like that, you leave all of them default, it's going to get confusing really quickly. So if you have a name, this one is Michigan DevFest. I spoke at Michigan DevFest a month or so ago. So this is just an example. I already created the database because we have the connection strings, and I don't want to show the connection strings on, here, especially tweeting these slides out. You'll be able to mess with all my stuff. You can get started. It starts creating and provisioning that database. It takes a minute. It's not going to do the whole entire thing while we're here. Come on, go down. I was going to 2x this. We're going to secure it. We're not going to secure the cluster. I'm not really concerned about that. As long as you don't have my stuff, you're good to go. We're going to change the connection parameter to connection string. And we're going to take that connection string, and then you're eventually going to take that connection string and you're going to paste it into Compass so you can connect, but you're also going to be using that connection string as your environment variable. Put that in the code. You also put that in the app console and the app platform as a global environment variable. That way everything is talking, everything can be connected, and you'll be hooked up to your database. So it's pretty sweet. This is what you do. You do a new connection, you just copy and paste your connection string there, save and connect or save. And if everything works out, then you're gonna connect and you're good to go. If you do some configuring on the DO side, it might block this from happening when you lock down your cluster, but there's IP issues and stuff like that, so that's why I didn't secure the cluster. It automatically connects. Ooh, I can't even see the time. There we go. This is kind of the structure. This is the structure of the app that I built. We have our components. That isn't like the React style, so you have your components in a folder. I like to make a components folder inside that folder of the component itself to keep everything separate. I'm an old school web developer, so I like keeping everything separate. I'm not a fan of CSS inside your markup and inside your JavaScript. Things should be separate. That's just my opinion. I'm old school. And we have our types. So we have our components, our pages, which is just the index.tsx, and then we have our types laid out. The MongoDB type comes directly from Mongo. The index comes directly from Mongo 2 and Next. And then the encounter type is just what I had to create. So this is the pages index. You just bring in a bunch of stuff from material. You're going to bring in your encounter card, which is the card component. And you bring in all your types. You bring in use state because we're going to be changing the state on search. We have this index here. So let me go back. We're just exporting a lot of the Git server-side props that comes from the Next and Mongo integration. You set up the collection. The client DB is called close encounters. The collection itself that's holding that data is called encounters. You add a find, a limit of 30. You return that with some props. And then you just catch some errors. So this is in the index.tsx. This really all comes directly from that command that you're running, the next Mongo command. And then this one is the actual information, right? So we're exporting a function called home. Above that, we are setting the search and the set search. We actually have the search component right there. So if it's lowercase, we're searching, we can do the incident name, we can search state, we can search the city that it's in, and that will filter down those examples for you if you're looking, if you have a big database, right? And then we're going to return that data. We have the head of, this is all material stuff. This is coming from material. So you have your title, which is UFO encounters and sightings, right? Your meta information, if you have any links like a favicon. We have our header right here, which is that green one at the top. That's a totally separate component. We set a container with material. We put the search bar in there. We create a box or the main component that's going to hold those encounter cards. And then we bring those in right here. We set a little bit of CSS grid. Love CSS grid. And then we just pull in those filtered encounters. And then that's just the footer, which you don't have to worry about. And then we have our header.tsx. It's very plain. You just bring in the app bar, the box, toolbox, typography, stuff like that from material. And then you create your header. You just create it. You create the function. You export it. You bring in the box, put your information in there, and that's just what it looks like. It's UFO encounters and abductions. It's kind of your standard header that is 100% width. And we have the search bar. So we bring in more material. And we just create the search bar. We have the box that has the CSS that's going to make that box work. We have the text field inside, and the text field has all the accessibility properties built into that component. I've walked away from the accessibility community for a little while. Big web accessibility advocate, traveled all over the world and talked about these things. But text field is already accessible, and it comes with already a label. And then just some typography at the bottom, just to say, hey, this is what this search bar is for. Use it at your own discretion. And that's what it looks like, right? Your standard text, you can type in it. It's got the little disclaimer at the bottom. Come on. There we go. And then we have the encounter card, which is the one piece that makes all of this up, right? The one piece that's consuming the data. We bring in all that material stuff. There's a lot of stuff for material. So if you're used to working with design systems and big monolithic things like that, there's tons of stuff. If you roll your own design system, I'm a big fan of rolling your own design system. That is one of those things. You bring that in. You bring in the encounter props from the types. That way you can structure that data that's coming in, and it's using TypeScript, so you kind of have to.
Manta and you can do the research, the government will admit that it now exists. Don't know how it works.
Did you plant it?
Yeah, I was gonna say that's a plant.
Did you plant it?
No. Like people at age, yeah. I don't even know. It's good. Well, it failed, which that sucks. But hey, this is live coding, right? So let's try this. Let's
Live deploying.
live deploying. That's what. Yeah.
That's a higher stakes.
Has anybody else had encounter before? It's okay to say it here. Unless they're being watched. No? Anybody ever see anything?
Those, but I work at Walmart, so I see lots of those.
They are walking among us. So you do have a good point.
Are they at Walmart?
I think so. Hopefully this works. It's probably not going to work, which is a bummer because I literally just tested this yesterday morning.
Oh.
That's okay though, because we're having a good time talking about UFOs. It does work. I can show you.
Does it say on the console?
This is localhost. It works, right? So, like Roswell, we can do that. Pump this up a little bit. Betty, if we wanted to search Zimbabwe, this is the Ariel School UFO sighting. This is a really good one. A group of kids at the Ariel School in Zimbabwe, they saw a UFO land. They saw unidentified beings. I think it was a group of 25 or 30 grade school kids. Right out back behind their school, they were playing, and it was recess. And they saw it, they didn't know what was going on, took off. 30 years later, they interviewed the same school kids, and they all still had the same exact story. You would think after 30 years it might change, right? It's like a game of telephone. Every single child that was spoken to, from when they were in school, now they're all in college, have kids or whatever, it was the same exact story the whole entire time, throughout the whole entire 30 years, right, or 20, 25 years later. So, but that's a good one. Phoenix Lights. Anybody familiar with the Phoenix Lights? Phoenix Lights is pretty sweet. Happened on my birthday in 1997. I was not born in 97, but my birthday is 313. Go Lions. So it happened on March 13th, 1997, Phoenix, Arizona. A big Delta type craft that was lit up. People saw it all over the place. I also too believe the same evening, Kurt Russell was also flying a plane and saw the Phoenix Lights over Phoenix, Arizona.
Is that what he saw? Is that the Manta?
I don't think so, just because that one has like space lights. What I saw had like straight lights going down the side of it.
Yeah, because the Delta like was kind of like this, but it was more of a triangle and not like that. It had lights kind of going all around it. So
okay.
But there's a bunch of them. The Rendlesham Forest. Anybody familiar with the Travis Walton incident? Fire in the Sky. You ever seen the movie Fire in the Sky from 1993? It's a creepy movie, but Travis, there was him and his friends. They all worked in like a logging company. They all worked in the forestry business. They were leaving the job site one night. Huge light ended up in the forest. There was a huge craft that was shining down. Travis got out of the vehicle to see what was going on. He got blasted back by the radiation or something. His friends split, and they said, "Oh no, we need to go back and get Travis." Went back. Travis was gone. He didn't show back up for 5 days. They found him full unclothed inside of a payphone. What are those things called?
Phone booth.
Phone booth.
There you go.
A phone booth. And he found some change in the ground, called his family. They went and picked him up. And to this day, he travels all over the world and he talks about what happened in his abduction, his sighting, stuff like that. So, Travis Walton, that's a really, really good story. Did this deploy? No, it didn't. It failed. That's okay. You'll get the picture.
What are in the logs? The console logs.
So we don't have time for that. We tried. It's Men in Black. They didn't want me to do this. I'm tapped. I'm sure there's wonky stuff happening in Dallas, like the Marfa lights that happens in Texas. You know about the Marfa lights? We can talk about the Marfa lights. I love this picture. That's not me or my dog or anybody in my family, but it's pretty fresh. What did we learn? We learned how not to deploy UFO data because I'm being watched. We learned a little bit about UFO history. We learned a little bit about Next.js, MongoDB, Compass. I hope I made you proud, Jesse. DigitalOcean. If you ever want to use it, let me know. We can talk about these things. We can talk about UFOs if you want. It's storing data in Compass using MongoDB, deploying that to the cloud. Thank you so much. that's the GitHub if you want to just keep continuing to add to this. I had this going through Hacktoberfest. Michigan Dev Fest was happening through Hacktoberfest. Hacktoberfest is over now. But I had a buddy of mine, he was contributing to this and making it a little bit better. So if you want to, the code's out there, have fun. I want you to believe, I definitely believe. Thank you, enjoy the rest of the day.
Is there one after this?
Not in this room.
Not in this room. I could have kept going then.
Yeah, but you guys, you can all enjoy the rest of the event. I don't need to be selfish and keep you.
Yeah.
Appreciate it.
Good job.
Yeah. Let the organizers know. Let everybody know, like, DeMars, they gave a sweet talk.
Oh, yeah.
Yeah.
No, this is mine.
Alright.
This is it. I don't know who's this is, but it's not me.
Did you give the talk that you got this at some point? I'm trying to remember. I know I saw one of your talks. I can't
Where
remember.
was that at? Was it virtual?
Yeah, probably.
I may have.
Maybe it was. I can't remember.